for the both GPS and IEEE for 1588 for the PTP. We target a throughput of the more than 1 Gbps, covering like what do you call it 4x4. But our roadmap goes for even 8x8. I think maybe like 3 to 6 months down the line, I'll provide a default solution 8x8. Okay, these are the trials which has been done over the years. One side, looks very good on paper in terms of the, it's all like a POC volumes, what we get. Our equipment, especially the 4G femto, it's been really trialed in the CAPS Austria, actually Austrian company, which has been put into Europe, which is they complemented our solution, but it is only entered into only the POC stage. So our another solution which we deployed in Tasik, Indonesia, where it is mainly meant for band 28 application for the defense. In obviously, like we have been awarded as part of the SOF, developing the micro base station and deploying in Kolar. We have 20 sites which are running in the field, both 20-watt platform and 40-watt platform, which has been given to general public, where the people use, obviously specified customers. This is part of the BSL network in Kolar. We have been awarded for the 5G labs in India, like say the last 6 months, which is the equipment is running in the NPTI Ghaziabad. It is the National Power Corporation Institute, which is running as part of the 5G labs, which is part of that 100 5G labs. Okay, now I think you guys can be a little interactive if required, especially for the private networks. Okay. The typical the private networks, what we usually envision is like a 5G radio, 5G core, centralized server managing those things. The other on the terminal side, like so we have quite a few elements like security, the video surveillance, the production monitoring systems. Okay. Be it equipment inspection. This is the typical, any private networks will be taking care of this, where we have the radios and core networks, the edge computing platforms, IMS systems, all those things will be part of the system. Okay. With this in coming to picture, like say I would like to see that if some of you wants to go to the what you call, either you want to develop a system, you want to be integrator, you want to be what you call develop use cases, right? To try to see which segment you want to enter in, because it's a pretty big field. Even though we call private networks, it's a pretty big field. It's a very I always say like this: the people will not take our solution just because it's cheap. Like say they require still a high quality solution, should work 24/7. Okay, and so then the features should be like as good as like any tier 1 vendors. So keeping that in consideration, different verticals will have different types of the quality of service. So you need to look into that, which vertical you can fit into, depending on the quality of the product what you are bringing in. Okay, so if you wanted to put it in everywhere, like say, it will be very hard. That's what I believe in. Okay, even though I do many of the stuffs, sometimes I regret, sometimes I have to move forward, keeping in mind the where the business opportunity as for the reasons itself I have. Okay, so you guys take a look at it. Okay, the first biggest private network is railways. Okay, so even though it don't look sound is a private network, but at the end of it, you guys has realized that it is a private network. It's not given to public, right? It is a what are you trying to address in the railways here? One of the biggest, see, for everywhere, the typical products. What do you have? A radio, a core, maybe edge computing platform, the IMS, and the terminals. When you say terminals, like the mobiles, the indoor and outdoor CPs, all those things, right? Okay. So, but each vertical, each private network will address different sets of problems. That's where you can differentiate. For example, railways, what does differentiate? One of the biggest is like say, because it's a train is a very fast moving vehicle. So that means when the train is moving, you need to take care of course, in India, like we are trying to achieve like a 165 kilometers per hour to 200 kilometers maximum. But Europe, like it goes to 350. Somewhere in China, the people call 350 kilometers to 500 kilometers, right? Or Japan. rather I can say. So the one of the biggest challenges with the speed. Speed translates to your the frequency Doppler shift. That problem you have to address primarily in the layer one and the algorithms what you do for the Doppler effect, right? That's what you have to do. This translates to because so much shift, right? You guys might be looking at like every 5 kilometers one cell will be there, every 2.5 kilometers, every maximum in the GSM region like will have used to have a 10 kilometer, 20 kilometer sites. Those are shrinking really, like 1 kilometer. The cell sets are really shrinking. Now you can think of railways, the whatever the RFPs, what they circulate today is like around the 4 to 5 kilometers is one cell site. Okay, so when the train is moving such a speed, like say you need to have a frequent handovers. So your network should be capable of. So that problem is you need to address is from the base station to the what you call small cell base station to the micro cell base station to the macro base. So there'll be a lot of overlap cells. You need to have different algorithms to take care of all these things, especially to frequency handovers. Okay, so I'm trying to put, but what is the market size you guys are trying to address? It's pretty big. So it's almost like a 10 billion. That's because last I heard from in the general public news is like 60,000 crores for the infrastructure, thinking that 1 kilometer a crore, 60,000 kilometer lines we need to address. Okay, this network, I'm talking mainly on the Indian side. Okay, here. So especially in India, right, we need to integrate some platform called Kavach. Kavach is the flagship railways, a platform where it takes care of both security side, the anti-collision system. All the applications will be taken care by the Kavach platform. The infrastructure has to be integrated, like say a cab station and terminals at the train to the network, the base stations, all those things, right? We'll cover the infrastructure side. Okay, can MSMEs can address this market? I say the no and yes. Okay, so it depends actually. But at the same time, be it like the government of India initiatives, even Resonus, we got a 30-kilometer line somewhere in what you call in Bidar. We got where we are trialing our network. We cleared the first the trial in the labs, but now we moved on to they provided a 30-kilometer line, which so that we will be eligible for the future tender. So that means there is a possibility that the company like MSME can enter through a system integrator, not as a direct company, like through system integrator, which who are capable of a financial capability, they can enter into that. Okay, so whether you can go to global, yes and no. Once we address these markets somewhere in India, but the problem statements are pretty big. You guys need to understand. If you take one vertical, please, my personal opinion, stick to that. If you address that itself is a big market, okay, but it's a tough one. Okay, next market segment, what the people, if let's say you guys want to talk about is the defense. See, whatever the markets I'm talking about, sometimes mainly talk about India and where we can really address. I'm trying to see that. Okay, when you go to the defense, right? The one of the biggest network what the defense guys will be looking at is network in a box. When you say network in a box, because most of the defense segments are not, it's a movable, because there is the army, air force, these things, right? They'll be keep wanted to move. So this is actually the Bell equipment, Bell station where the mast is keep on moving, right? They want to have a network in a box where the base station core, the IMS, all in a single box. And one is the simple box which should be deployable in a what you call jiffy, like just put it should work. Okay, so that is the requirement what the defense guys brings in. Another thing is like a what you call it should be scalable. Like say if I want to put some 10 15 sites or 50 sites, all should be interoperable each other in a segment of less than around 10 kilometers a square kilometers line. Okay, that's what they would like to have. Another the challenges what we bring in the defense segment is like they always ask for a customer security requirements, because it's a really secure network, like where they will be operating in the enemy lines, right? So you should have some of the features will be like a custom uniforms, like say if I use a standard telecom waveform like when I say waveform, right? 5G LTE, sorry, 5G NR, 4G LTE. These are the waveforms I call. Like a GSM is a waveform, right? Because standard waveform. So they'll say that some modify such a way that where the standard wave terminals will not be able to latch on. If someone has the mobiles, like our mobiles, like a custom mobiles, cannot latch on to the public networks. So that's what they would like to have. So one of the biggest challenges what we'll have is that they always wanted a custom mobile, so that uh, it will only work for the particular segment. Today the challenges are like where do we get these custom mobiles? Because today, if you really look at that, only few vendors globally like Qualcomm and MediaTek, if I know, right? Those are the guys. They never open up their kernel and L1. Kernel sometimes people open up, but L1 never opens up. So you cannot change the waveforms. Even L2, L3, right? You cannot change. So if you otherwise, where do you provide your custom security? That's the one. Some of the challenges. Some of the Indian chips, the mobile vendors trying to venture into that, try to see the be developing the chipset at the same time, at least using the either Qualcomm and MediaTek chipsets, trying to do some customization so that we can make some differentiation, mainly meant for the defense. Okay, okay. Obviously this what are the opportunities exist in defense? uh, Pretty big market size, if you ask me. Okay, I have a request from different parts of the world, mainly from uh, some of the countries. Actually, not some of the countries. One of the countries which are operated. Okay, they keep on asking, saying that, can you provide a custom network? Where they think, like say, they tell me that I can provide you um, a million mobiles order with what you call a 20,000 to a lakh networks, even though it's in paper. But the thing is, there is intent in that. Okay, uh, but today we can only enter into like a 20 30 sites or 50 sites. Okay, we can enter into that. Only good part of it is there is no cost pressure on this. Like say you can select really at good price, where if you have a gestation period of minimum of 1 to 2 years to realize the money, it requires typically at least 2 years. So looking at that, you can enter into the segment. Okay, nowadays like the people call like a 5G private networks, right? This is where really 5G comes into picture, where the people has the attractive. Even though I talked about the railways and the defense, right? uh, you can operate in the 4G or the 5G, and which is very complicated. Earlier was both railways and defense has their own spectrum. Okay, so far we were not able to enter into any other private networks, because where do you get the spectrum? That's the biggest challenge for all of us. Okay, but railways and the defense was provided by their own spectrum, and like vendors like me can provide the complete infrastructure solution. But there is a change coming to a 5G. I'll talk about that. Anyhow, the enterprise side, typical, like say, be it like a campus networks, be it like a manufacturing segments, right? They were looking at a enterprise segment where you have to provide a 5G SA core. It typically goes to mainly small cell. 90% segment will be small cell. Some will go with a micro. um, the other key challenges, like they expected a automation and AI part of their thing, but the typical performance, like a number of users, like a most of the case, I think like a 1K, the maximum case 10K we can go. The coverage is like 1 square kilometer is the typical coverage I can imagine as of now. Maybe some cases like a mines and all, you have to cover a little bit more, but this is what I can think of. Some of the networks like what you call will be around a kilometer. The biggest challenge what we face here is the you need to integrate with the legacy PLC. Most of the elements here, they especially terminals, the device, right? PLC controllers and all. So you need to integrate. Even though if you talk about simple infrastructure like a 5G as a pipe, you don't have any problem. But when you go to enterprise, right, they will expect that end-to-end solution. So that's where some challenges will be integration with the terminal device. If you simply think that I'm providing a pipe, I absolutely no problem. Just put our equipment will work as a be it Ethernet, be it a optical network, be it a wireless network. It is just simple pipe. Obviously, the QoS will differentiate from the 5G, but I'm mainly talking about the integration, and where they will embrace you very easily is the into their network. For example, if you talk about the PLC equipment as part of their manufacturing space. No, the biggest challenges comes is where do you get the spectrum? Okay, then many of these people, right? They operate in the Wi-Fi. They think that it comes up. Yeah, hey, I put 2,000 rupees. I'll get the network in the Wi-Fi. Okay, even though they might be selling out the big price for the complete enterprise, but how the people think in the short-term memory is like, oh, I'm using the Wi-Fi network, which is very cheap. When you come to 5G, it will be very expensive. That we need to address, even though both technically and the what you call perception-wise. Because if you talk about 100 Wi-Fi device which you want to cover 1 square kilometer, if you put the one 5G network, it may be much cheaper. Okay, but difficult to sometimes change the perception. One of the challenges will be size of the network, right? Like say people will be looking at maximum 10 base stations, 2 base stations, right? So you need to address a different customer and different integration expertise, and they think that they don't want to the as a vendor, right? I cannot charge them the a POC charge. They say that, oh, you just give me the service to me like any other guy, like a Wi-Fi guy gives, but this is not possible with the 5G network. Little integration efforts required, definitely. So this when you are entering into the enterprise segment, this is the ifs and buts. The spectrum, obviously, I'll cover later. One of the things is today, BSNL is trying to give spectrum as part of the same PN. Otherwise, there is no way that in India you can operate in the private segment because the enterprise cannot get their spectrum. Okay, BSNL wants to lease its spectrum through CNPN. Maybe I'll talk later. All right, the 5G campus network, which where the lowest hanging fruit I can think of, where the quality of service is not that great, requirements are there. Okay, which I can think of is the we are trying to provide a complete network where we provide the G-Node B, 5G SA core. Okay, what you call the CPs. It's a complete ecosystem. Okay, I do not think that I can. I'm providing from in-house products. No, only thing is I can provide internet network, but through a lot of vendors, the ecosystem which we have. Okay, one of the things is when you say campus networks, like say as a campus you want to operate and do the service for the internet or broadband. Second thing is the students for an education use case development perspective. I think that's where the important thing is. Where we provide a mechanism, what you call a complete network can be provided, where you can show the PCAP logs. Simple, one of the cases is just they want to understand how a 4G network or 5G network will work. In this case, 5G network, right? How the 5G network works. Like logs at terminal, mobile, logs at the base station, logs at the core will help them that, hey, this is the way it works. Be it a standalone throughput case, other cases the handovers when you are moving from one cell to other cell. We can provide two base stations for the handover network. Okay. Other thing is the people wants to do the research where they want to provide their own solutions. Like say, for example, I provide a G-Node B. They want to put their own core. In the G-Node B itself, I can provide a, I think the previously our people told that different options of network, like, right, different options of the network, like where I can provide CU, DU, within that 7.2 splits and all, right. I can provide NFAPI split where you guys can bring up ODU, L1 algorithms, okay, and CU. So both open source you can take it up, be it like a what you call, you can develop your own algorithms and do, and you can integrate and improve your solution. That's mainly from the research perspective. Practically, if I really think of most of the 90% of the segment we'll be looking at, just how it works itself is a great exercise, because many people may not be knowing, even though day to day we use the mobile phones. Okay, how it works, the system access to, like say, that means broadcast data to random access channels to what you call attach, in this case registration, to the PD stations to what you call handovers. This simple process itself will give you a great picture for you. One of the biggest thing is, where do you get the spectrum? Especially the DOT has done a great job. Very simplified approach from the Wireless Planning Commission. Just you wanted to deploy campus networks for the both trials and spectrum. If sub 20 dBm, you can just online, you can download and then trial it. So you don't require any approvals. Just put a 5,000 rupees, you get a spectrum, and you can do your the trials and testing. Okay, it's just very okay. Other the addressable private networks. See, I'm trying to put it. What are ifs and buts in the networks? If you guys want to venture into use case development, mining, smart grid, and traffic, we all have. Okay, everything has its own ifs and buts. The troubles. When it comes to mining, mainly rugged and reliable networks is required. Vendor, I'll say that for every private network, I'll say yes, but it has its own challenges. If I put my network today, mining, it'll just what you call the because the chemicals what it will emit, the temperature what it is operating in, okay, it'll just go to smoke in maybe in a month. Okay, there is a challenge will be there. It beat terminals also. Some of the cases like a low latency like services like URLCC, those challenges are there. You need to have a really low latency services that less than 5 milliseconds, less than 1 millisecond is the one. Today I operate the 15 milliseconds to 50 milliseconds is the my ping latency is concerned. Okay, because the high speed throughputs, I have to venture into 5 milliseconds throughputs. The latency services plus the bandwidth has had to go 1 Gbps to 2 Gbps. I'm targeting near future for up to 2.4 Gbps. Going forward, I want to go to 5 Gbps. Okay. The obviously the entire market size is pretty big. The one of the challenges, especially mining and all, even the most of the people don't know like not addressable what you call solutions available. Frankly, okay. So if the mining, it's all most of the case government sector. They want to take the equipment from us happily, okay, but they want to have entire equipment at our cost, the POC at our cost. So whether who will pay for the POC, no one knows. Okay, but if someone wants to address it, definitely there is a big market scope is available. If they want to what you call a specialized equipment, they will not have much competition. That is a good thing about it. You want to put this particular segment, you will not have much competition. Okay, most of the equipment today work on a tetra, like a walkie-talkies. The previous the Abhijit was mentioning, right? The walkie-talkie solutions and all, right? Those people are operating in. When it comes to here, like all those services, video surveillance, what you call autonomous vehicle management, the digging the equipment, the crane operation, all those things you can work differently. Okay, you are in India. Just I want to glance it. Just let me see what is the time. Okay, okay. I'll try to put the telecom updates in India. Let's see, you are mentioning to India, right? What is there in India? Why do you want to really operate from India? Okay, so what is the global stuff? So I think 2-3 years back, really government of India, I think the government current policies has kept it huge demand. One is the demand is perspective. Okay, another perspective is like a what you call definitely attractive opportunities in the subscriptions, in especially in the 5G. Almost 350 million subscribers people are envisioning in 2026. The especially policy support. The what is changing in see spectrum itself is unheard of for testing even. Okay, how do we get the spectrum now? It's so easy. Just online, you just go WPC website and then you can download what you call trial license. That easy they made. The policy support is tremendous. There is a huge investment from the government of India. So that is the way the advantage of India. I'm little simplifying it. Everywhere there is quite a few problems are there, but um, both devotee and government of India really helping the industry and even the telecom operators as you know in a big way. Okay, so some of the numbers what you can think of in 2022, there's a 5 spectrum actions happened. You know that most of the operators got at reasonable prices. Okay, the finance ministry told 5% of the SOF fund, so almost like a lakh crore is in the SOF fund to be given to R&D. It's a pretty big, and I'm also big recipient of the grants from the government of India. Okay, whether that is good enough or not is a question mark, but it's a pretty big and which is unheard of. Okay, a lot of design-led manufacturing schemes are going on. If I want to apply, you want to apply, you will get it for sure. There is no bureaucracy. It's a pretty straightforward. There is a misconception people will be having that whether you get it, there is a bureaucracy there. I'm telling you, if you're a really serious player, if you're really genuine, just apply, you'll get it. Okay. There are BharatNet. There is a big program is going on, right? They wanted to cover like BharatNet phase 1, phase 2, phase 3. Big opportunities available for any vendor you want to pitch in, or any system integrator wants to pitch in. There is a big thing is available. Or or you want to put a use case. There is something called in the BharatNet, right? Village level entrepreneurship program is there. If you guys are not aware, okay, where you can take one village where you provide some internet broadband services, some be it education services, you can charge the customers and do it. It is part of the BharatNet program, okay? So you guys can venture into that. CDOT as a pioneer in the telecom domain, they themselves has a almost like 500 crores funding, okay? They're giving, even I'm the recipient of the CDOT fund also too. So you guys can embark to see that. And CDOT is one of the things they are providing is they are trying to bring not only the financial support, there is a machine to machine communication. They have a strong IoT platform is available with them. So if some of you wants to really go in, uh, they integrated, they develop some protocols where you develop your IoT device where you can interoperate and integrate with their solution. Okay, I'm moving to BSNL because if you ask me that where do you get the opportunity to deploy my network today, if you ask me, public sector, okay, even small scale, I don't think so. I really get an opportunity at the private sector. I'll not blame the private players, telecom players. I'm not ready for them. Not that they want to take it from any telecom vendor, they want to take it, but they don't want to compromise the quality levels what the Ericssons and they're giving. At the same time, am I capable of supporting them like 6 months to a year in their networks? Today, I'm not capable, but the BSNL is the one which is supporting us through Government of India. They given me SOF. It is onus is on me to deploy it and then serve this BSNL well. Railways, they gave me 30-kilometer line. Maybe defense, I do well. If I take the same equipment to the, I think Airtel, the Jio and Vodafone, they happily embrace. But as a vendor, I'm talking about from my perspective, I'm not ready because it requires a lot of financial aid. So that I definitely would like to take. Maybe this is not the forum. The government of India will try to put it in some efforts to help us. Okay. All right. So I'll try to put the Indian market outlook here. Okay. Just this is the mere numbers. It is not my numbers. What has been in the public domain. We took it by 2026. This is the big numbers as the segment is concerned. Okay. Macro dynamics. It is like the just you guys try to glance like Europe is the one of the things where I can go as a private enterprise customer. I just pay few euros, really few euros. I'm telling. I can set up my own network. You won't believe that the operators will shell out billions to set up a network to get the license. Whereas in Europe, like say $100 to $100, I'm telling, it's really you can get a one small private spectrum license operating in a small region. So even though there is always debate happens, one side I'm spending the money, like operators spending the money in billions. The private network wants to spend a few dollars. Can but you have to understand that one is a macro dynamics. Here the small scale dynamics where the private operators will operate in a square kilometer region. So you need to understand that. So yeah, industry, you guys can look at the China is one sector where they're doing pretty good in terms of the both vendor ecosystem and all. India is trying to catch up. Okay. These are all standard numbers which is coming from the GSMA. Okay. This is the what are the private network opportunities what we have. They expect like 1 million companies will be expected to the 5G networks. When I say companies means like the private networks, okay, the enterprise networks, okay. So some 60 to 70 billion euros is the one which is estimated, and almost 2030 another research 64 billion is the one which has been put. Okay, the challenges. Okay, I'll try to look into the technical challenges and the business challenges. 2 slides I kept it. So technical challenges we look into that when I'm developing, right, which network I have to develop, a small cell, micro, macro. So when I say that people want to look at it when I'm looking at private networks, better go with the small cell, maximum micro, telco grade, go with micro to macro. Okay, even though small cells are really going to be a big in even the telco world for the femtos and the small cells. Okay, but whether you can go and then address that telco market, currently I'm doubtful, but never know. Most of things. Okay, chipset. There are many chipsets available. Some are like Marvel, Qualcomm, Intel. Okay, some are like general purpose solutions. Some are very license based. Okay, pretty expensive. I'm telling you. Which target you want to say put it, enterprise and telco grade? I said ifs and buts of everything. Then what is the team size you require? What is the technical capability you would like to have? Okay, this is completely debatable. Okay, one side as a company, what you call small in size, whereas you look at the Nokia Ericssons, they have 10K to 1 lakh the workforce trying to deploy, and they're bleeding. The bottom line is today. Okay, so it will be say that I try to achieve the same quality and service. What they do, it's a little question mark. But the bottom line is the customers don't look at whether small or big. They wanted the same quality of service. So which segment you want to focus on, depending on your technical capability and team size, what you have. And the next few things I talked about is the investment size, what you put in, what is the time horizon. You want to develop a telco grade equipment, like a horizon should be 1 to 2 years minimum to realize your the investments itself. Okay, even get the revenues and all. The challenges is the ecosystem, both in the hardware and software, right? One of the biggest challenges in the ecosystem in India is the I think the hardware. Okay, like where do I get my PCBs? Where do I get my the boards? Where do I get assembly? Some of the cases we are addressed. Where do you get my chipsets? Okay, for everything I need to go to the
Excuse
Singapore.
me, Mr. Subaya.
Yeah,
Excuse me.
I'm almost done.
You have 3 more minutes.
Yeah. Okay. The biggest challenges here is the private networks are where do you get my spectrum? The spectrum is CNPN, the captain networks which has been given by, and who will pay for my POC? Most of the cases, right, which is changing is the NCNC, no cost, no commitment. Okay, that's the challenging for the small companies. Uh, but government of India is coming with a different schemes like a paid POCs. Railways is a paid POC. What I'm getting. Okay, SOF is a paid POC for me. Okay, so there is a change in the spectrum. Earlier, it is unheard of. Only NCNC. So commercial relation timeline, you need to look into railways, defense, mining. Okay, uh, you want to compete globally. You want to compete with Chinese. Uh, but the only good thing about that is most of the Chinese products has been really banned. So that is the opportunity for you. Okay, but at the same time, definitely you need to look at the quality over the period of time. What those guys achieve, you need to achieve. Volume and cost. Today, all our volumes are pretty small. You need to, in order to achieve the cost spectrum, right? Because customer definitely don't look at today still gives a low volume, but expect the price at a 10K volume or a million volume. So that is a challenge you'll be facing. All right, man. So I'm done. You need to, if you have any questions, you can ask. Thank you.
Yeah, thank you very much, Mr. Subaya. It's time for questions. Are there any questions?
Yeah.
Okay. Any questions, please? Go ahead. Hello? Okay, if there are no questions, let's thank Mr. Subbiah for an excellent overview of 5G networks, private networks, and the business that he is conducting in Bangalore. All the best to you, Mr. Subbiah.
Thank you.
Thank you very much. Thank you for taking the time to address this workshop. So let's move on. The next speaker is Dr. Vinod James. Are you there? Yeah, you are there. Yeah, excellent. Yeah. So welcome to you, Dr. James. Um, Dr. James has a PhD in communications from IIT Madras, and today he is the Director for Technical Standards at Qualcomm International. I think it's the Bangalore site. He has been with Qualcomm since 2011 and has served over the years in roles spanning technology and standardization. He has responsibility for Qualcomm's standardization engagements in India. He is an expert technologist with years of experience in product regulation. He engages Indian and international stakeholders on matters related to radio standardization and regulation. Dr. Vinod is the convener of 5G India Forum and is a committee member of various regulatory bodies. He is a prolific speaker and serves as academic advisor to several research scholars, and he is a senior member of IEEE. So it's over to you, Dr. Vinod James.
Thank you. Just checking my audio is fine, and then you're able to see my screen.
Yes,
okay,
we can
great.
see. Yeah.
Thank you, and then happy to be speaking in this platform. I'll be a little honest in here, so I really don't know who my audience are going to be. So I prepared it in a manner, if a organization is interested in 5G, what are avenues for them to participate? What sort of, is the business motivation? Of course, the previous speaker also alluded to it that, startups need money. Where does the money come from? If the trial needs to be done, we need seed money and other related things. So I had tried to focus it on from that particular perspective, trying to give insights on where 5G is being applied, and specifically going to focus on industry verticals, which particularly means it's not your mobile phone, it's not like a FWA or other application, but in industries, right? So, for example, if a railway needs 5G, then what will be that they be using for? Or if you're saying that I want to put it in like a airport or other related things for. I think I stopped the share. If somebody is deploying a private network, then what exactly that particular thing means, right? So those are sort of the motivations I want to give, and I have a huge deck, but I think it will fly off quickly. I want to really reserve the last 10 to 15 minutes and see if there are questions, because that's where most of the exchanges will happen, in my opinion, right? So without taking too much time, let me just go through it. So probably you guys know Qualcomm. We are the ones who are powering most of the smartphones. So our idea of what technology should be like is like in this one slide, right? So our thought is we need to enable a world where everyone and everything can be intelligently connected, and then empower people, right? So your mobile phone or your FWA is the everyone. Everything is all the applications we are talking about, and that's where this particular thing is going to be talking about. So yes, 5G happened. Globally, deployments are happening. So where exactly are we with respect to 5G, right? So how many operators have enabled it? How many different territories have happened? So 310 plus operators have basically deployed it as of May 2024, of which 124 of them are standalone only, right? So vis-a-vis India, we have Jio, who has a standalone network. And then, Airtel is now starting to roll out standalone deployments. And as of, again, May 2024, we have about 2.1 billion 5G smartphones which have been shipped globally through the OEMs. And, quite a lot of use cases are actually coming in. right? So I give a hint in here, right? So you're finding it applicable in laptops, in cars, automotive, several other use cases. So, okay, Vinosh, from a Qualcomm perspective, what exactly is 5G, right? Is the new radio 5G or is something else 5G? So for us, 5G or 6G or 5G advanced, whatever for that matter, is defined by what particular 3GPP specification based on which somebody is building a product, right? So to be even more clearer, as you see in this particular slide, release 15 of 3GPP specification is what was first called as 5G. And then there were two more releases in 5G where the different features and functionalities were addressed. Then came 5G Advanced, and now we are working towards release 20 specification, which will have 5G evolution to the majority, and then 6G study is actually happening, right? So products are mostly available up to release 18. So release 15 to release 18 is what is marketable or commercially available today. So that is what is 5G for us, right? So reiterating, 5G is basically release specific. So all the features and functionalities really, defined in a release 15, 16, 17, or 18 is what 5G is about. And the way the industry is evolving is trying to find out, how to have one technology roadmap, which means, have one silicon, and that silicon then goes and finds applications in several other elements, right? So why do I emphasize on this silicon and not on other related stuff? Just to step back, all these innovations are actually powered by R&D. And R&D involves cost. So there are two aspects of R&D which at least I am comfortable with. One is what we call as commercial R&D. And the second branch is what we will call as societal R&D. Commercial R&D is about what is marketable, what is sellable, and where commodities can be manufactured in large, right? And we like it or not, the handset silicon is what sells and what scales. Primarily because it is also controlled by the telecom service providers, and they have control on the network side OEMs as well as the device side OEMs. It's again a symbiotic sort of relationship. There is a clear transparency on what is needed and what will translate into revenue. So that market grows organically based on the commercial needs. There is silicon, there is firmware, and then there is software. All three need to work hand in hand so that it actually works on a particular telecom operator network. Now, when this silicon becomes available, doesn't matter whether it is infra silicon, core silicon, or most importantly, the handset silicon. If that can be leveraged, and then a lot of applications can be done on top of it, then the commodity drives a societal value. So when we do societal R&D, our principle is leverage the commercial R&D outcome, in this particular case, the silicon, and then try to build software on top of it for applications which you are interested in, right? And again, if that ecosystem is also very aggressive and very pushy, then it also gets pushed into that commercial part, right? So for example, automotive, or if you are talking about laptops, other applications, including your smartwatch, consumer IoT, and other related things, it is slowly getting into that commercial R&D derivative part. Meaning there is also an aggressive ecosystem building around, right? So let's differentiate these two elements on what commercial things will push and where societal elements will come in, right? So for example, the railway application or other use case, my previous speaker spoke about, the success is going to be higher if you are able to leverage some of these commodities, right? I'll be revisiting this in a bit because it's also needed for some of the other things which I'll be talking about. But let's hold on to that for now. And then when we mention about all these features which became part of 5G or other related things, what exactly that is, I just try to catch them up together in a single slide for you, so that across releases it becomes available. I'm hoping that the organizers will be asking for the slides, and I'll be happy to share the slides as well. So when we do this, you will get to see what are all those functionalities which actually come in. And in this particular topic, I'm actually going to focus on 3 industry verticals. One is about industrial IoT, or how 5G is finding application in Industry 4.0. The second thing is about automotive, specifically focusing on CV2X. And the third thing is about broadcast, specifically how 5G can find application in the broadcast sector, all outside the purview of traditional operator things. And as you see in the slides, there are like evolution happening across releases. For example, NTN, the original work started in release 17. It's progressing in 18, and then it will also have things in 19, 20, and others. So why 5G? Why it's like very important? Because during the design of 5G itself, as you'll see in the next slide, when the radio interface was designed, several of these use cases were anticipated, and what I would call as placeholders are already part of this planning. So the design, as it evolved from release 15 and coming up, is intended to be general purpose like. Meaning, if you're talking about a very bandwidth intensive applications, the framework allows for it. If you're talking about very sensitive, time sensitive or other related applications, there are provisions. If you're talking about having IoT like applications, which is like very low data rate into this, you can do that, right? So it's like a flexible air interface which was developed as part of 5G. And then the idea is, okay, now that I have this flexible air interface, how to actually make it commercially viable, right? So switching tracks from technology development to business use case, what we did was when 5G became available, we basically set up a study trying to find out, how and when we try to find application of 5G, which particular industry vertical is going to be rewarded in the commercial sense, right? So there are at least 8 of them put together in this slide, moving from precision agriculture to construction and mining, education, connected healthcare, mobile experience, smart manufacturing, intelligent retail, and smart city. A collective of about 13 trillion US dollar in economic value is anticipated by 2035, right? So we still have like 11 years to reach that, but that 13 trillion then interests the market, right? And if somebody says that hey, I am actually interested in doing something in it, but I'm a startup, where should I actually focus on, where the returns are likely to be high to do commercial stuff, then this provides like a beacon point on where do you start looking. So when I mentioned that I want to look into 3 sectors, it's basically on the construction and mining part, which is about the industrial IoT or other things, or specifically on the smart manufacturing related things. Smart city for the CV2X part, and then smart rich mobile experience for the 5G broadcast related things, right? So typically about $10 trillion is what I thought I'll focus on for this particular part, right? So okay, great. In a real life, where do I actually see it, right? So if you are from, say, for example, the central part of India, around MP, UP, Rajasthan, those sectors, you typically try to see very large fields, people doing agriculture, including Punjab and other areas, people doing agriculture in scale, and the trend is going towards automation. So if I tend to automate, what are the avenues for me to automate in there, and what are all those individual elements which I can actually focus on, right? So I'm just providing an exposition in here, trying to find out how to actually get stuff for us. You'll see that there is this autonomous harvesters for pest detection. You need to fly drones and other related things. you need to have, this AGV sort of, moving around and then doing stuff. You need to continuously monitor the environment and then, periodically sprinkle stuff and other related things, right? Focus on a small problem in here. Yeah, if you are a startup, if you are basically trying to leverage the use case labs and other related things in that, you will be able to find a problem for you to work on and then tap onto this particular opportunity. Or if you look into healthcare, uh, again, very similar things. There is 5G private network to be used in here. Why private network and not the public network? Because a lot of material you will be actually seeing in this particular domain will be sensitive information. So that needs to be maintained privately and then managed privately. Right from managing the inventory within the hospital to record management to record tracking and other related things, you can actually create and deploy a customized network for a particular hospital chain, right? And these hospital chains are only growing, and then they have their own market. Or if you are actually looking into, say, for example, classrooms, what are those applications, where digitization is actually driving, or how these things can be actually helped, right? So again, very similar things. Assuming that I have given sufficient background on where you can actually tap in, let's look into those use cases we are interested in, right? So first one is about industrial IoT, right? So just focus on this particular video for like a brief. So as you would see that in a particular application in like a typical factory floor, where everything is expected to be automated, you have AGVs, industrial robots, edge analytics, computer vision, sensor, head-mounted displays, handheld terminals, all need to work in real time and leverage a lot of these functionalities which 5G was designed for, right? So remember, three aspects were supported. There was this broadband evolution, which they call enhanced mobile broadband. But from a factory floor perspective, you have tons and tons of sensors which qualify for massive IoT. And then a lot of these informations need to actually come in very short time, right? So for example, if you're actually doing precision cutting, a few millisecond worth of latency will ensure that you are actually wasting resources in where you're actually doing that cutting, right? So 5G basically leverages a lot of these stuff, including in ports and other places, where, for example, tracking these containers in here, managing that, they get into the right ships, ported, loaded, tracking, centrally monitoring and other related stuff. 5G NR can actually help industries do it, right? And when I say can help do it, work has already started in that part, and then huge lot of work is already going on in there. I see a question. I think I missed it. We will come back to that, Chetan, soon after I finish this flow, right? Just hold on until that point. And then, just going back into the same application, I think I'll skip the animation and other related things for a brief. The key thing is, from a industry perspective, is in addressing the question which comes in the next slide, which is about, if you have private network, how do we ensure that they are designed to be dedicated, secure, optimized, and then leverage all these functionality, conforming to regulations and other related stuff. And most importantly, this is how these industries actually look today. You have servers, you have controllers, and then you have a lot of these machines which actually leverage Ethernet and other functionalities today. And just because you brought in 5G, nobody is actually going to replace those machinery and other related stuff, right? So the real question is, how can you actually enable this industry by making that seamless in adoption and then agnostic for the industry flow, right? So from a machinery perspective, there should be no difference. It's just that wires have been replaced, Ethernet has been replaced, and then you have wireless Ethernet all coming through 5G, which the standard supports, I think, as of release 17. Right? That's where the real money is, if I may use that word, right? Not necessarily the technology and other related things, because the technology has been proven to work in this particular framework. The question is how the technology can be put to use by leveraging the enablers in the standard, not just in 3GPP, but across IEEE and other industry bodies as well, right? So if you are able to solve that problem and then give like a comprehensive solution, you are in business. And there are like several industries which will actually benefit with this particular automation. Moving into the next theme, which is about 5G broadcast. The theme is very simple, how to make terrestrial broadcast working. So you will all know that OTT is driving the mobile traffic as of today, and then why it actually interests Qualcomm is like we actually power devices, and from a Qualcomm perspective, anything you are actually seeing on the screen is actually a device, right? You have your phones, you have your XR, AR, VR devices, it's a device. The dashboard on a car, it's a device. Your digital TV, it's a device. Your FW and other things which is actually enabling it, all are devices. So it's the same problem, right? There is like this silicon which is available for the mobile handset. Can that be leveraged to enable a industry vertical which traditionally shied away from mobile, right? So when I say this particular statement, we are not talking about the cellular band, but we want to basically enable broadcasters who have their own broadcast spectrum to leverage cellular technology and then do stuff, right? So that's sort of, like the 30,000 feet pitch for what broadcast is supposed to expect, right? So it leverages the 3GPP silicon, which has a well-defined ecosystem. And then, this actually is trying to find out a place in, where alternate technologies like DVB, T2, DVB-I or ATSC3 broadcasting standards and others are coming in, right? What's the advantage for 5G broadcast? The advantage is, it's the same silicon which is in your mobile phones. So if handled carefully, it will be able to also do 5G broadcast, right? So that's sort of the idea. And then, it runs on UHF spectrum, reuses infrastructure which like a Prashar Bharati or some other private public broadcasters will have, not just in India, but also in places like Europe, China, and other places. It comes with quite a lot of these functionalities, and the standard keeps evolving, right? So when I say that, these standards keep evolving, I just try to present in here a list of some of these things, which we did. So two things to point out that within TSTSI, the Indian SDO, there's a report available since April 22, which tells, how this it needs to be implemented, how it's actually made possible. And then these standards are also adopted by TEC into national standards, right? So if you are implementing it, you are basically implementing an Indian standard from that particular perspective, right? And what is the advantage it will bring in? The advantage is, you are basically leveraging the ecosystem of handsets, which is already there in the market. If you are already having DVB content like an MPEG or other related things, you continue to leverage the same platform because 5G broadcast is compatible with the DVB, and all the DVB assets will be able to be translated on top of it. It's a proven ecosystem, and since it's a handset again you are talking about, if you are leveraging 5G broadcast to basically send emergency alert other related messages, your handset will be able to receive it, right? So not just about the broadcaster, it's about also PPDR like applications which can be enabled in this particular purpose, right? So that's on broadcast. Moving into auto or the CV2X technology which we are talking about. The whole gamut of how this industry is evolving is the following, right? You are moving away from, if I may use the word, analog cars to digital cars, which means your dashboard is now able to tell you, how much pressure is there in the tire. Do you have fuel in the tank? How much you are able to do it based on, what your previous driving patterns is like, is that sufficient to drive you 30 kilometers, 50 kilometers or whatever it is? Or, depending on, which particular point of the day you are driving, it asks you, are you going to work today or, you are having other plans, and a lot of these integration is actually happening, right? So how is it actually possible, and how do you actually leverage it? I'm basically presenting a suite of opportunities which Qualcomm is exploring across geographies, right? So maybe for India, the smart transportation is like a good thing because you can do good traffic management, or the intelligent cockpit is of interest to us. If you're talking about the Western countries, then maybe we are talking about autonomous driving, how to basically help that particular ecosystem thrive in that particular place, right? So it's a case by case basis, and then again, we build the silicon, we build the technology, we basically talk to car OEMs or their tier one, tier twos who are actually supplying them with Qualcomm technology, and then ensure that we enable them do such work, right? So when I say that we enable them, we also have labs in India where we encourage these OEMs, tier ones and tier two, to actually come experience and then work that, right? So I think a few blocks away from where I'm actually doing this presentation now, we have a Qualcomm Technologies lab where I think functionalities for 4G, 5G testing, RF band, sub-6 millimeter wave, NB-IoT, EMTC, all those capabilities are actually there, right? And you are encouraged to basically talk to Qualcomm in enabling those sort of things. But that's just a pointer to that particular part, right? And when you talk about building capabilities for a car, again, we didn't have to do anything new for the car, fundamentally new for the car, right? Let me be careful, right? Meaning it was not like a new market we were trying to look into. It was basically trying to leverage the platform, what we call a Snapdragon, which was available with it, which had the modem, meaning which had the connectivity, which is like 2G, 3G, 4G, 5G. And then it had the RF front end needed. It also had other things like Bluetooth, Wi-Fi, and other related things. Most importantly, the platform had the security and other functionalities needed for that. And then, it is already AI enabled. So when a car OEM decides that, we have to basically leverage this functionality, all that they would aspire for is already available in that silicon, right? And remember, I keep talking about this silicon because this particular silicon, which was commoditized because it was built through a commercial path, is now leveraging a lot of these societal values, right? So why am I actually mixing a car with a dashboard to a societal value? Because the moment the car gets connected, several other societal benefits like managing traffic or helping insurance companies give you better tailored plans, or in the case of 5G broadcast, we were talking about how that can be also used for emergency warning alert and other related applications. So that's what this particular thing actually enables. Some videos in here, how this cellular V2X is actually beneficial or other related things. I think the next one is the real animation. So if you're talking about the side link information, then the whole idea was there are cars on the roads, there are vulnerable road users like a person going on in a cycle or a bike or other related things, and then there are pedestrians. So the cars need to be able to talk to each other, telling that, hey, I crossed just this road and I'm actually seeing this particular blockage or other related things, and exchange that information between cars. Or, it should be also able to transmit it to the infrastructure so that that smart city, which is actually coming up, will be able to leverage such information and then make a lot of analytics out of it, right? How is it possible? It's because, there are like three fundamental elements to it. The car is actually talking to each other through the side link, which is the CV2X part. The car is then able to talk to the infrastructure or to the telecom provider or to the roadside unit, which is basically coming as part of the cellular network. And then, there is also Edge AI built into those infrastructure elements, which is able to make this real-time diagnostics or information gathering part, right? And this CV2X is going to be very, very critical component to our vision on how this society will work, right? So there is vehicle to vehicle, vehicle to infrastructure, to pedestrian, and to network, all powered by this particular chipset which we are mentioning in here. And happy to discuss more about it. I'll skip this slide, go into the next one, which is about standards and other related things. So the moment you talk about standards for automotive, it's not just the radio part. You need to also talk about safety specification. You need to be talking about wireless charging related things. BIS has like a suite of standards which need to be conformed with. So when we say that we have a platform, we also ensure that we meet the regulatory criterion needed for that particular platform. I think I will slip this animation. If I'm not mistaken, I'm already reaching the end of my deck. For example, this is a smart city framework which you are talking about. It will actually help you do better traffic management if you are the smart city provider. If you are like a platoon company, then it actually helps you manage your fleet. So, for example, your Ubers, your Blue Smart navigation companies, or your BMTC or other related traffic vehicle companies, they will be able to leverage these benefits and then do better planning, which, if you look into it, translates into efficient running time, minimizing on fuel, or ensuring that the passenger gets to reach from point A to point B using a better direction. A lot of these benefit actually comes into the system, right? Again, these are all benefits. These are all can be tapped with technology. The question is, how do we actually build that technology which will actually ensure that somebody is able to find use for it. With that, I will stop. I think I was at least able to convince you that there is value in taking 5G to the verticals, and there is opportunity for somebody with a real appetite to actually go and make I would say money out of it. But please feel free to ask questions. I think that's the only way we will make more sense out of this conversation.
Thank you very much, Dr. Vinod. The floor is open for questions. We have time for questions. Somebody has raised hand.
Moises, please.
Please go ahead. Hello, Moses Papignano. Please go ahead.
Moses, if you are speaking, you are still on mute.
You're on mute. Hello.
Yeah. Meanwhile, let me try to take the 3 chat messages on.
Yeah, please do. Yes.
Shivashankar asked, is please share your excellent request. Okay, so I will definitely share the slides. And then Chetan asked, when I understand there are no 5G network focused regulation. DOT issued the guidelines for sharing and access spectrum. Okay. Do you foresee any upcoming regulation around 5G? If you are talking about the EMBB use case, more specifically to the operator spectrum.
Hello.
Yeah, Moses, please go ahead.
Yes, Dr. Vinosh, thank you very much for your brilliant presentation. I'm Moises. My name is Moises Antonio da Conceição from Angola.
Mm-hmm.
At the moment, I'm speaking from South Africa because I'm here for some time.
Okay.
And my question is, looking for the advantage that 5G technology is bringing to all the fields, especially in industry. Yeah, do you have any forecast of employment until 2030? That's all. Thank you.
Okay, so it's a tricky question. Let me try to at least answer from a Qualcomm perspective. So from a Qualcomm perspective, we expect 5G to be there probably from until 2040 or beyond. Right? So for the next 15 years at least, 5G will be ruling industries, will become the foundation for 6G. And any new thing coming on even in 6G or other things, it will be backward compatible with 5G. So if somebody is investing in 5G, in trying to be like a startup, MSME or other related things, you are guaranteed that you will find a market for 10 plus years, which is beyond 2030.
Thank
Okay.
you, doctor. Thank you. Yeah.
Sure. Going back to Chetan's question, so from the EMBB perspective, DOT or its sister wing, the TEC, they have come up with a guideline, not just guidelines. They have regulations which need to be adhered to. This includes how much will be the emission, what is the spectrum band that need to work on, and several lot of stuff. The industry verticals we are talking about, they also have specific standards. Some of them come from ISO. So for example, the automotive safety related standard come from ISO. The radio standard, they come from ITU or from 3GPP or from TEC based on those sort of things, right? So it's a mixed bag. Even from the India perspective, the radio part, which means, whenever there is like an emission of radio waves, that will be defined by the Department of Telecom through TEC. And the non-radio aspects will be standardized by BIS in the relevant platforms, possibly through the corresponding nodal ministries. Okay. Ravi Teja, please go ahead.
Hi, so I have a question. I wanted to know if there are any, are you aware of any deployments in factory use cases that you were speaking about worldwide? It could be worldwide, but any real use cases if you're aware of.
So Industry 4.0 is picking up big time. If you are talking about countries, Germany is leading in this particular domain, right? So even in India, if I'm not mistaken, Foxconn, they have enabled their their factory. They have made their factory 5G enabled or industry IoT enabled, and so are I think 2 or 3 of the automotive manufacturers based in the south and in Gujarat. So meaning the Chennai region as well as in Gujarat, they have also automated their factories. So yes, large scale players who benefit immediately from this particular process, they have gone ahead, right? I will also provide you one more information. So in Europe and in US, a lot of these airports and naval ports or the seaports, they are also in the process of migrating towards using this thing, right? So again, if you look into it, those entities have like huge investment potential. So and then they value coming out of it is actually like huge for them. So they have gone ahead. From a smaller industry perspective, this is still work in progress. So yeah.
Okay, thank you.
Just to add to your point, a lot of these hospital chains have also started doing it. So although I wouldn't want to classify them as industries, if you are like a private network provider, there's no difference for you. Hospital versus industry.
Okay, thank you.
There's another question, I believe.
Are there chipsets from Qualcomm with respect to V2X communication? If yes, have an individual you can reach out to us. I think I did mention about one of the chipsets we had in this slide. See if it is this one, right? The 9150 CV2X chipset, which is available since 2018. So that is there. If there is interest, I can connect you to the corresponding business BD lead, who can take it forward.
I have a question.
Yeah.
You are the director of standardization in Qualcomm. Okay. Does that role mean that you actually, there is a lot of standardization in the chipsets that Qualcomm is making? So I wonder whether you have to, in some way, connect and homogenize or harmonize different standardizations involved in 5G work versus chipsets and so on. I don't know whether it makes sense, but I'm wondering whether your standardization role is as wide as that.
Okay, good question. That's most of what I do, right? So now that you made it personal, so I think from 2006 until 2013 or 2015, I was involved in the development of these standards, which means I was going to 3GPP. I was part of the team which actually developed LTE standards and the other specifications, right? So if you look into the 3GPP specification, it only defines the inner working framework, meaning a chipset from Qualcomm, it goes into like a iPhone or like a Samsung device or something else. This needs to now talk to a Airtel or Jio network through a net which was deployed by Nokia, Ericsson, Huawei, whoever it is, right? So there are like several of these players involved. The standard is only defining what will be like the message exchanging framework to be in here, so that it is able to solve that recurring repetitive problem. And once this framework is in place, somebody has to build a product. And when the product is there, it has to conform to local regulation. So in around 2015, I actually changed track and then started doing what is called as product regulation, meaning a device, in this particular case, Apple or Samsung is making, will have to be able to imported, manufactured, and then if you're on travel, you should be able to take it without fear that this is not conforming to local regulation. So that product regulation is the part which actually play now. So I have seen both the sides of the standardization.
Thank you. Thank you. Are there other questions? Okay, if there are no further questions, let's thank Dr. Vinod James for an excellent presentation, very informative. And thank you for taking time to talk to the people here gathered in this today workshop. Thank you very much.
Thank you.
Please share your slides.
Yeah, there's a question from Divya. Should we take it or we just?
Yeah, please go ahead.
Divya, please.
Thank you. Yeah, thank you, sir. I thought I didn't communicate well when I raised hand. Thanks for noticing it. Sir, I have a specific question of in the process of adapting and implementing the 5G or expanding it throughout different industries, how are we actually taking care of the security aspects of the technology itself, not the the devices or the industries? Specifically with 5G technology, how are we actually, what can be done from the technology part for security aspects?
I'll be careful in my response. So when you say security, there are two aspects of security, right? One is the communication security, meaning I am exchanging some information. It is actually transmitted on air and then reaching the other party, right? A standards body like 3GPP only specifies the security needed for that particular air interface transmission to ensure that that is not intercepted. I think when you say that security is handled, you are talking about the application layer security, which is typically
actually, as a technology, like the security standards that is involved in 5G is what I'm specifically asking, because application, it largely depends on where it is applied and what other technologies or devices or hardware is used on the application side. So, I mean, I think that is a collective effort. I understand that. But as a technology, 5G alone, standalone technology, how the security aspect is taken care of, and what maybe if there are any regulations specifically for that in India that we have. And there could be some that is taken care by the technology itself, or some can be by process. So that way, I wanted to understand an overall insight on that, sir.
Okay, again, two things. So whatever is needed for the standard is already defined in the standard. From an India perspective, there are actually three entities who are responsible for it. There is TEC, there is the Department of Telecom, and then there is MIT, So Mighty has a standard for, I think it's called STQC, Software Testing and Quality Control Center or something. They have a standard to be conformed by all the peripheral devices or the IoT chipset and other related things, which are being used for uh, mainly for the societal applications. TEC has also come up with a best practices document on how to actually secure, I think it's called consumer IoT devices. So there is a best practice document for consumer IoT, and when it is commercial aspect, there is a STQC standard on how it has to be implemented. You can always relay that question to me privately, and then I should be able to point you to those regulations.
Sure, sir, sure. I can understand. So you told me like 5G itself has some security part of the standards, right? So like what I meant specifically in that is that like how are we adapting? Like for example, just as an example, we know that 5G as a technology has roaming security enhancements. For that, we have end-to-end encryption and mutual authentication. While the data is actually in between communication with different networks during that time. So where this is a standard that is available in 5G as a technology, but
Yes.
how are we actually, like there will be some adaptation process or methodologies that we will be leveraging that, right? So that perspective I wanted to understand, like whatever is available in security is available in 5G, we might use some of them can be implemented, some of them might not be feasible at the moment. So that way, we have anything that is is there somewhere that I can refer to maybe or understand where I can know what is leveraged and what is adapted from the technology and what is feasible for us, for our region, for our environment, for our infrastructure or something like that.
I can check with my colleagues and come back. I'm not a security expert.
Sure, sir, sure.
I'll come back to you.
Sure. Thank you so much, sir.
Thank you.
I hope I didn't trouble too much.
No, that's okay.
I'm sorry.
Thank you very much.
Thank you. Yeah.
Are there any other questions? If not, thank you, Dr. James, for taking your time out to talk to us. Thank you very much. The final talk for this morning session is by Ms. Usha Padmini on India Open Source Mobile Communication Network Program at the Indian Institute of Science. She is an alumnus of IASC, has a master's degree from EC department of IASC, and has rich technical and leadership experience from CDOT, Lucent Technologies, Hughes Software Systems, Alcatel-Lucent, Nokia, and Mavenir, and has in-depth knowledge of how telecom technology has evolved from RAX to CDOT to 5G open source over the decades. So she is going to talk to us about India Open Source Mobile Communication Network. Ms. Usha Padmini.
Yeah, thanks, Shiv Shankar. Good afternoon, everybody. It's always
You have
interesting.
45 minutes, ma'am.
Yeah, thank you. So it's always interesting, right? Just before lunch or just after lunch, we tend to get. Let me get my deck open. Let me share. Give me a second. You're able to see my screen, right?
Yeah, we are, but it's not on full screen mode.
Okay. It is full screen for me. It's not?
Not here. Yeah. This happened yesterday also. I don't know what the problem is.
I don't use Google Meet often, so must be some setting somewhere. I don't have any extended window either. Let me see if I share the full screen, okay? If that goes away. Doesn't seem to allow me to select entire screen. Yeah, okay. Is it better now or no?
It's full screen now. You may go ahead.
Okay, thank you. Okay, what I will do in this session is introduce what we are trying to do in ISC as part of this project, IOSMCN. What is the motivation, and briefly introduce the project. What is our architecture, where we are at this juncture, and who are our partners, how we are planning to move ahead in terms of governance. That's what I would be covering. I think today morning you had heard how private 5G has immense potential, though it looks like now that 5G is completely deployed in India, though the users are not as many as 4G, 5G looks a bit late to start. But you just heard from Dr. James how it is expected to stay for another couple of decades. The primary reason being the full potential of the technology is not yet utilized at all as of now in the deployments. We are still in EMBB and still in macro networks. Private 5G is getting deployed in some of the advanced countries like Japan, US, Germany, etc. Very interesting use cases, but still for the kind of potential that it has, where we are, it is as of now in very nascent stage, I would say. So TSDSI has worked with many of the players in India in telecom and came up with a white paper about, I think, 3 years back. And this proposal, the root of it was embedded in that. It's available on the TSDSI website for anybody who's interested to see. The whole mission and vision is to democratize Indian telecom industry with open source. So which means we need to come up with a solution and make it available for Indian ecosystem to be able to innovate a lot faster and deploy and utilize 5G as a technology. This is, as of now, funded by Ministry of IT and Electronics, though we expect it to expand beyond that. Already we see beginnings of it. This has started earlier this year. And then the idea is we bring academia and we also bring a lot of industry. And we also formed a core team across 3 strategic partners. The strategic partners are from ISC, IIT Delhi, and CDAC Trivandrum. This is a consortium as of now, and there is work happening towards this mission. So the idea is when we, any new entrant to enter telecom was kind of impossible some years back, let us say 5-6 years back. Open RAN kind of changed the scenario to a decent extent where a lot of players have started coming in across the globe into the industry, who could get in, either do one or some parts of the whole RAN. Otherwise, the RAN, which forms almost like 70% or more of the deployment cost as well as revenue, which depending on wherever you see yourself on, it was all just held by a few handful of global players. Whereas now, a lot of players are coming in. And given that this is also a capex intensive market, it would take a decade for it to break that barriers completely. I can see within a few years, we are already there to some extent. The next step, which can revolutionize the whole thing, is to be able to give 5G, at least the base stack and solution, decently ruggedized as an open source. So this was conceptualized based on that philosophy, this whole project. It can help in multiple ways, also in terms of any academia research for 6G or 5G advanced, or any specific use cases by many players in Indian industry to be able to innovate in a very localized use cases as well. Without a fundamental stack or a 5G, otherwise they will have to invest crores and crores of rupees just to develop the basic solution of 5G. The idea is, once we have something like this in place, that entry barrier can be taken away. What would be the value proposition? I'm giving this for our first kind of year. This is not like a very long-term stuff. So what we figured as part of our study is, any open source that is available today, there are a few of them globally available. None of them give a complete end-to-end solution. So the idea is we prepare something which is a complete tested end-to-end solution. And also, none of them are kind of decently tested. So we will try to get RAN, core, SMO, RIC, and IMS as a complete solution. And then any of the Indian ecosystem startups can leverage this open source. They can develop customized innovation on this. So we found different sources that are available have quite a few basics as well missing. I'm not even talking like release 16, 17, 18. I'm talking even 15 and some of the 16 3GPP release features itself. So right now we are focusing to get these two done, and also do basic stability traffic model testing, because that is another thing which we found missing in most of these open sources available. This is where the complex piece, typically in a 5G, based on my almost 3 decades of experience in this wireless space, I can say we tend to overlook this part. Developing something at a POC level is one big step, but it is still like 10% of the whole fun in the game. When we really develop a proper engineering system, even within the labs, is the next big thing. The final thing, which is like 60-70%, is ruggedizing and optimizing it in field. So we will go through these steps. Right now, obviously, the focus is in the first two. The idea is next year we will get into some pilots. So we are looking at more automated test coverage. We have already started on this journey, and making the continuous integration process more robust than the available open sources, so that we increase the test coverage. The idea is when you open up eventually, the overall strength of this solution is about how much we can test as we develop more features. We are also looking at a lot of Indian radio vendors integration, because the existing open sources, they have not integrated everything. So far, only VVDN has been integrated. So we have also done Lekha. We are about to start on Tejas. And long term, as I said, different applications are as relevant to the Indian market. So the solution, I think most of you who are aware of basic 5G solution stack can relate to this. We are looking at, as part of this program, both the RAN as a unified version and as well as distributed version. As of now, the RU is left as third party. At some point, we will also try to get the unified version on a complete solution, like RU plus G Node P. And then we are looking at kind of two tracks where the unified version as a monolithic RAN will interact with core SMO and IMS. Distributed RAN is more of Open RAN compliant. So we will get to have a complete F1, E1, E2 interfaces and the RIC implemented as part of this. So that's the whole idea. We have two types of tracks as a solution. One for those who would like to go for unified, and one who would like to go for distributed. In terms of our license strategy, any of whatever we would like to develop on our own, we are planning to go with Apache V2. This makes it simpler for anybody who uses them compared to other licenses like GPL, which kind of mandates anybody who uses to be able to deliver it back in terms of the code. Apache V2 gives the most flexibility. And then we also did a lot of base code comparisons for different solution components. And where possible, we are trying to stick to Apache V2, because anything we inherit from any existing open source and develop further, we have to inherit their license terms as well. Though whatever components we develop over and above will stay with Apache V2. So we will have, once we establish, we are planning a first release end of this month. We will have the release level license files and everything. And once we have a proper solution end to end, and we open up, any contributors will have to sign up with different contributor licenses. This whole model is nothing unique with iOS MCN. For those of you who are exposed to open source in general, this is kind of a common practice across the globe, including Linux Foundation. So our in terms of our GitHub structure, we had planned it like anybody who can pick and choose, who want to pick and choose can do that, or who want to pick the full solution can do that. So the idea is we will have each of these components as separate GitHub organizations and repositories. And then all the images put together, we will do a complete end-to-end solution test. And when we deliver them as a combinatorial also. So depending on the users who may want to pick some or all, right? That flexibility will be there. And there will also be, in terms of release, it can be at individual component level or an overall at iOS MCN solution level. Okay. as we are about probably 6 months into the whole program, we have looked at the governance structure to start with. We had looked at the GitHub structure and the workflow processes which can sustain long term. So the study has been done with respect to how Linux Foundation operates and how different other open sources operate. And then the whole governance structure is planned accordingly. We had studied with our some of the partners some of market requirements from Indian market specifically for private 5G, and then looked at the relevant technical requirements from 3GPP. And also we studied and compared different open sources available across the globe for all these components. And we have finalized for RAN, core, and SMO, and already implementing the first solution. IMS, we are expecting to close by September. So we will try to get Vivo and are going after that. So we have integrated, as I said, VVDN, Leica, 7.2 front hall for 2x2. And then we both RAN and core, and we are kind of integrating these with SMO for management plane. So we have achieved decent throughputs both on RAN and core. DPDK was brought in for core. And then for lab conditions, at least we got decent throughputs. Now we are looking at expanding in terms of the capacity and stability. So we got 24 hours stable, sometimes 48 hours, up to 4 commercial UE. We have now established a complete simulation environment to be able to scale this for 1632 users, mobiles testing, and also for future to increase the number of RUs. We have both the RU simulator and in the process of getting a UE simulator. So we will have test beds already right now. Functional test beds with commercial UEs are there. We will be expanding it to more simulation based test beds as well to be able to do different traffic mix. One of the key thing in the industry for all the telecom infra R&D units, right, for Nokia's, Ericsson's, Samsung's, etc. The key is to be able to do this kind of test, which mimics the field the maximum. So next steps wise, we are preparing, as I said, the first internal release by end of this month. And then we are preparing for a demo and launch at IMC in October. So as I said, we are covering all the basic features needed for 5G at this juncture. We expect that to be robust very soon. And then we started focusing on capacity, stability, and performance, these aspects beyond the functional. And we just started evaluating RIG framework. We plan to bring in very soon. And once we have these, we are also already working on a couple of pilot deployments early next year. So that way we can ruggedize this for the whole solution. And as a step beyond that, naturally, we would like to expand the ecosystem of user community. As of now, this is more of an internal strategic partners, some of the development partners from industry, because the solution is kind of getting ready. Support for development of any use cases for Indian market or expanding this to release 16, 17, any research areas. In fact, we are also discussing with the Art Park team how this can be made available. And some of the DOT 100 5G labs can also use it once we release this. And in the long term, right now it is all based on Intel platforms. We are interested to expand this to other hardware platforms based on the demand and need. So broadly, I would say this is the path we would like to pursue in this project. So just to give a snapshot, in just a few months apart, we started off at just the top tier, beginning of the year. And then we had expanded to various development partners already, who are classified as platinum, gold, and silver. So the ones on the platinum, Simnovus, who develop a lot of test tools, RU, UE simulators, etc. And we have Tejas Networks, who will be bringing in their RU and would be working with us. We are in the fag end of signing off the MOU. Almost done with everything else, just for signatures. CDOT again. So the CDOT is actually planning a innovation lab for 5G, 6G, and the idea is we will collaborate with them to be able to have this solution taken there. For anybody from the startups can either use it as a black box or use it as a white box once the source code is available. Airtel, who has vouched support in terms of helping ruggedizing this once we have a solution ready from our lab. They can give the specifications or test in their labs and help to make this more ready. There are multiple partners who also, Lekha, Neeral, Rebecca, different members are trying to give a different type of contributions. And CIT, Tumcourse, you can see a mix of industry and like some academia, CIT as well as MSRIT. So different industry partners are kind of interested in different value add props that we have at this juncture. So as I said, we are organized exactly like Linux Foundation, how they operate. We have a governing board, operating committee, technical oversight committee, project management committee, and the whole work is organized as sub-projects, and which get tracked in our weekly meetings of PMC and kind of bi-weekly for technical topics for in TOC. And there is an operating committee to take some operational decisions and final directional decisions by governing board. So this is the way we are structured, and either the partners that I talked in different categories in the previous slide, they kind of have representatives or people, engineers working in different sub-projects, or their CXOs part of these committees. So I think anybody at this juncture, if they're interested, they can always reach out to us. So the value proposition obviously will be the visibility and recognition, so credibility, as well as to be able to steer this whole direction in the way they see how they can benefit out of it as they join in early. So that way we can get into more of influencers. It's kind of expanding already quite fast. We are discussing with at least 3-4 more startups who are interested in different verticals of what private 5G that they want to capture And some of them may have only one component. They want to use the other components from IOSMCN and go and bid. As I said, the uses that they are seeing benefits, each one has their own. Some of them have test tools and they want to improve their test tools and use IOSMCN, as we build a more and more ruggedized platform. This is what I had. So I can take questions.
Yes, please. Thank you very much, Ms. Usha Padmini, for introducing the audience to the very innovative program at IAC and the CDAC and the IIT. Questions, please. Hello, questions?
Go ahead, Divya.
Hi, ma'am. First of all, a very good session. Thank you for so much information. It's very helpful. And ma'am, my question is specifically about since we are using Apache license, how can we actually strictly adhere to the patenting part, because it is actually open source, right? Also, there will be challenges in strictly adhering to the patenting when we have open source actually. So
Correct.
how do we handle that?
So from any of the users, like anybody who's already playing a role, they will already be, whether it is closed or open, it doesn't matter, to be honest. The point that you raised is applicable irrespective of it, right? Patent is a patent. Once there is a set of 3GPP patents that are held by different global companies, anybody who's going to write even fresh code and keep it closed as well, they will have the same problem. When you take it to commercial, you will have to align on some of these 3GPP FRAND agreements. So that is nothing to do with closed versus open. One key clarification. Having said that, we are trying to discuss with the ministers, right, ministry representatives, in terms of how, for Indian ecosystems, is there a way we can try to alleviate this problem to some extent? Those are still in discussion stage in different forums, but I don't think it has got anything to do with open versus closed.
Any other questions?
Thank you, ma'am. It helps. Thank you.
If there are no questions, let's thank Ms. Usha Padmini for an excellent presentation. So that brings us to the end of the morning session, first half session of this today workshop today. We meet again at 2:30 for a presentation by Dr. Abhijit Lele. So see you at 2:30. Thank you all once again. Hope to see you at 2:30.
Thank you.
Thank you.
Everybody.
Thank you.
चलो कर दिया वो तो सुधाकर सर देखना हाँ ठीक है चलो कर दिया
This is Wave. This is the Google Meet now.
no ये फेस पूरा entire
OBS
screen
का
OBS
इसी स्क्रीन पे रिकॉर्ड होगा
इसी सिस्टम में पढ़े
And this arrow, if I click,
that ribbon.
That-
There are certain dynamics that what you will act and intensive.
Upon the actual use. And of course, there is going to be large 5G and LTE based IoT devices which will be available onto this piece. So this is extract from the Bharat 6G Alliance input to 3GPP workshop, which happened
second half of the day's workshop, the two-day workshop. This is the final session for the two-day workshop. And I'm Shivashankar from the skilling team of Art Park. Welcome you all. Dr. Lele, are you there?
Yes, sir, I'm there.
Yeah, okay. So let me welcome and introduce Dr. Abhijit Lele, who is the speaker for this afternoon, and he is going to talk about intelligent connected mobility in the 5G era. Dr. Lele is a PhD from the Indian Institute of Science Department, and he specializes in wireless networks and applications of AI ML to various domains. He has over 25 years of experience working with various enterprises, and he has spent the last 10 years building connected mobility solutions at Bosch in Bangalore. As an entrepreneur, Dr. Lele was the co-founder of Digitech Telematics, one of the early fintech startups in India, and also Urja Links Technology, which focuses on AI-driven energy management. Of late, his interest has been to explore the intersection of mobility, 5G networks, AI, and large-scale IoT platforms from a vehicle safety point of view, and leveraging these technologies for smart, connected electric vehicles, especially two-wheelers. As I said, he's going to talk about intelligent connected mobility in the 5G era. Before we get started, Dr. Lele, let me just say a word to all the participants. At the end of this session, the session lasts 45 minutes. At the end of the session, we will be sharing a feedback link through this chat box. So I urge all the participants to look at the feedback form, a Google form, fill it out so that we can organize our workshops better in the future. Dr. Lele, it's your floor now.
Thank you, Mr. Shivshankar, for the introduction. So let me share my slides and so are they visible in full screen mode?
Not yet.
Not yet?
Not yet.
Okay. I have shared.
You may have to reconnect. I don't know. This has been a problem since yesterday.
Okay. Sure. I'll stop sharing and I will share it once again.
Yeah, we are able to see the slide number 2.
Okay.
But not on in the full screen mode.
Right. Just hold on. Is it visible in full screen mode?
Not yet. I don't know whether
Okay.
there's a problem, but as I said, there has been an issue with that since
Right.
yesterday.
Okay. So can I continue with this?
Yeah, go ahead.
Rather than spending time trying to figure it out, we will work it out this way. Okay. So good afternoon, everyone. This is the last session. I'll try to keep it as interesting as possible. And as we move along, maybe you can stop me if you have questions. What I'm going to talk about is intelligent connected mobility in the 5G era, or as I said, we are trying to touch upon the various use cases. In this presentation, I will only cover the mobility related use cases and maybe touch upon a broad overview of the other use cases that are possible in a 5G network. The idea of this entire presentation of this session is to give you certain keywords, jargons, or kindle your thought process in the direction of building good use cases. I don't think we have enough time to go deep into any of the use case, but I hope if I'm able to trigger a thought process at the end of this presentation or the end of this session to think about the use cases that 5G can enable, I think it will be time well spent. Having said that, now if we look at the broad spectrum of things that are driving 5G, so it's basically driving a multi-trillion dollar economy with precision agriculture, construction, education, retail, smart manufacturing, mobile experiences. I mean, you name it, and the domain has a 5G use case in it. As I said, we are not going to touch upon every part of it, but some of the use cases that I have highlighted here, for example, in smart agriculture, we have precision farming or smart irrigation, where the sensors are used to monitor the soil and the crop, and then various things like smart irrigation, they get activated or controlled based on the measured parameters. The number of sensors, if done at scale, can run into millions. The number of control points can run into millions. So basically, this is a very high density kind of a use case that will get enabled. If we look at smart manufacturing, then data from all the machines and all the sensors on the machines, including visual feeds of cameras, etc., can be analyzed for optimization of the shop floor. So this is a use case where high speed, low latencies of the 5G network get utilized. We have smart care or telehealth, wherein again, remote monitoring of the patients and then transmitting the data either to the cloud or making it available in real time to the doctors can be enabled via this. We have smart energy and utilities. This is actually a very, very interesting use case, wherein, for example, there are close to about 60 to 70 lakh transformers in India today. And even if we take the use case of monitoring these transformers, for example, is a very big use case in it. And transformers is just one example. It can be monitoring of, say, transmission lines. We have a couple of lakh kilometers of transmission line in the energy segment. Monitoring all of these transmission lines is a big challenge. It is a huge expense today. If certain devices can be enabled and monitored, that's a very big use case. These lines go through very inaccessible territories. Drones are being used to monitor these transmission lines. So it's also a cross-domain kind of use cases that get enabled by this. And we have smart city and education. We all know of this. So I'm not going to do a deep dive in the smart city surveillance, parking systems, expected time of arrivals of city transport, making the city more efficient, water management, etc. use cases. And smart education, content dissemination in a much smarter way. Interactive education are some of the use cases for high speed, low latency communications using 5G network. So this is a very broad spectrum, kind of gives you, I would say, 100,000 feet level view of where the use cases are and how the 5G networks are. And I guess over the last 1.5 days, you would have done a deep dive on the characteristics of 5G networks, what properties it brings to the table, what properties can be used. So anyway, we are not going to get into the details of all of that. Now, specifically limiting myself to Art Park, we are looking at 3 use cases. And as Sheila had discussed in the opening session, and probably it was touched upon in the other sessions, the first use case we are talking about at Art Park out of this Center for Excellence in 5G Networks is about the drone corridor. So as we know, the proliferation of drone is going to grow, and as the number of drones grow, there would be a need to regulate or monitor these drones, the way they fly, allocate them paths. It's just like the aviation industry. You know, when you book a flight from point A to point B, there is a set path that gets allocated, the path gets monitored. But this can end up being a very, very high density kind of a use case, wherein you have several drones in the sky. We have to ensure there's no collision. We have to ensure the path of it. We have to ensure that there is location awareness of the drone. So these are all high bandwidth, very low latency kind of applications. How do we allocate? How do we geofence the drones? So on and so forth. So all these are being looked at as a part of the drone corridor experiment that we are trying to do at ArtPark. Maybe we can have some other time a more detailed description of the drone corridor project that we are trying to do here. The other use case that we are trying to target at ArtPark is the factory digital twin. So this is all about instrumenting a manufacturing plant or a factory floor with 5G networks and sensors, which and cameras and lidars, which are getting their data into the cloud or at the edge device, and then understanding this data or understanding the creating a context awareness of the entire situation on the floor of the factory. So this is more or less like creating a digital twin of the floor of the factory. And then when robots or autonomous vehicles move around the floor of the factory, there are several use cases that emerge out of it, like collision avoidance, geofencing. And then if we have a milk run going on the industry floor, maybe certain fleet management use cases that come about it. In addition to that, based on this data, we can look at how the entire end-to-end process gets optimized. So this is what we are going to do at scale in ArtPark, wherein right now it would be a tabletop kind of an experiment, but eventually we will set up an entire test bed with a practical industry, and then we will look at enabling of various different use cases towards bringing in efficiencies on the shop floor. So these are the two use cases. And the third use case is where I'm going to go and do a deep dive, which is the mobility space. So the third use case we are talking about at ArtPark, in which I'm going to do a slightly more deep dive into it in this presentation, is intelligent connected vehicles, right? So we all know that for some time now, at least for the last couple of years, there has been a lot of talk about automated vehicles. We have seen startups coming on, research papers along the lines of what is called as ADAS, right? So automated driver assistance system. And there are levels of ADAS, right? So your level 1 to level 5. At the lowest level, it is like simple assistance. You get certain alerts on seeing an object, or you get certain alerts on a lane departure. So if, for example, if you see the latest vehicles from the Toyotas, the Tatas and Mahindras of this world, on your dashboard of the car, whenever you are trying to overtake someone, you will get a lane departure warning if you have enabled it, right? So this is kind of an ADAS at level 2, where the user is informed of his intent and his action, right? And if we then take this to the extreme case, we can actually do automated braking, we can do collision avoidance. There are so many use cases that emerge. So in the four-wheeler segment, I would say the use cases, or a lot of ADAS use cases, have matured a lot. There have been OEMs which have been working on it for several years. Even, in fact, we have Tesla, which is trying out autonomous driving. There are several other companies which are trying out autonomous driving. But most of these use cases, are driven by sensors on the vehicle, The analysis is on the edge itself. So you have some computational capability on the vehicle ECU or on the vehicle computer, if I may use that word very loosely. And then the decision is taken on the vehicle itself, right? There are certain use cases which are connected, but right now they are not very mature. So what we are going to talk about here is, if we are enabled to connect the vehicle to either the edge computing or to the cloud, or between the vehicles, if we can enable information exchange, what kind of use cases or what kind of problems we can solve. And that is where we are moving towards. That is, we are moving from a completely independent, unconnected decision making system to a connected, distributed, federated decision making systems which can collaborate with each other. And that is where the world is moving towards, and that is exactly what 5G is going to enable in this case. So one of the themes that gets enabled here is what is called vehicle assistance and vehicle safety, and we are trying to do a deep dive in it in the 5G context, right? So uh, a brief history of how this all started, right? It all started with release 14 of the 3GPP, which kind of, provided the CV2X interfaces. It had a PC5 interface with an RSU on the road, and then it enabled a V2I and vehicle to vehicle and a vehicle to person communication without actually going into the cellular network, right? So this was kind of a technology where you had an RSU, a roadside unit. The roadside unit acted as an intermediary to enable a communication between two vehicles or to a person or to an infrastructure. And this kick-started in the early stages of 2017, wherein certain use cases that were related to, let us say, if the vehicle comes in close proximity of each other, there was an automatic braking, or there was an automated slowdown of the vehicle, or when a pedestrian was crossing a road, the pedestrian was alerted in some way, or the beeper used to go off. So there have been several projects, and in fact, some of these technologies have matured to be inside at least the high-end vehicles that get enabled by some of these services. And then the other part of it was the vehicle to network service with the UU interfaces that got enabled. So the vehicle could communicate with the cloud, and the cloud then to do some computations, especially, the infotainment system on it. So mapping services, the fidelity of the mapping services really improved with these UU interfaces and the cloud services that got enabled with this interface. And then over the period of time, we are now at release 17, 18. Each of these releases are maturing, and a new set of use cases are getting enabled, right? So if we look at release 17, the reduced capability devices is something that we are talking about. We are talking about of non-terrestrial networks, so on and so forth. And I'm going to talk of some of these use cases that the later releases of 5G network and the characteristics that they bring along with them are capable of enabling. So what we are going to do is, categorize the use cases into some very simple categories, and then see what are the requirements, what are the challenges that these use cases bring to the table, and then discuss probably, the potential reference frameworks that can help implement some of this as we go along. So now let's look at a vehicle. Maybe I will stop here if there are any questions. I'm not sure. I didn't look at if anyone has something to ask. Okay. I'll continue then. Uh, so let's look at the car and the two-wheeler. So at a very, very broad level, we have, if we look at the road segment as such, or mobility segment on the road, we have an infrastructure where there are traffic signals. We have cameras at intersection of the traffic signal, and these are all networked today. We might have also dedicated infrastructure-based cameras, not necessarily at the traffic signal. They might be for monitoring purposes or deliberately installed for V2I communication. Especially, there are certain use cases of, say, parking slot detection, etc., which require certain visual sensing. Apart from a parking sensor, of course, parking sensor is one of the ways of doing it, but not necessarily the only way of doing it. Then we have the vehicle. The vehicle today is also equipped with a lot of sensors, right? So we have a radar on the vehicle. So in fact, some of the high-end cars, so having a front radar on and a back radar is very common. So for those who are new to this terminology of radar and lidar, uh, uh, when you drive your car, you put it into reverse, you are able to see the back image of it, and if you're close to an object, it gives a beep beep sound, right? So that is because the radar is giving a warning of proximity on the car. The radar or lidar depends upon the implementation from various vehicles. So we have the radar, the lidar. We have cameras on the car. We have certain ultrasonics on the car. We have tire sensing. Nowadays, we also have side sensors onto the car. Of course, we have location indication in terms of GPS. We have accelerometers on the car. We have vibration sensors on the car. So it is truly, completely the most sensed asset today in the world. Now, where it is getting evolved is right now the data that comes out from all of these sensors today is consumed by the car itself. Okay, for example, the application just that I described of a beep coming out when you are reversing the car, or when you are in close proximity of another object, there is a beep that comes in. So the data that comes from many of these sensors is actually just internally consumed by the vehicle. It is neither communicated to other vehicles nor is it communicated to the cloud, because until now there was no infrastructure available to communicate this information at scale, at that speed, and at that latencies, right? And this is exactly what 5G is going to enable. So now imagine all of this data that a car has from the various sensors that it is equipped with. If we are able to package all of this data and somehow figure out a way to communicate this data to the cloud to enable certain intelligent decision making, or communicate this data to another vehicle in its close proximity. How do we communicate? When do we communicate is probably where the reference framework comes in. A lot of different use cases can be enabled, right? So that is exactly where we are heading to right now. And that is exactly what a 5G network will enable. Now, what is the ADAS equivalent on a two-wheeler? We talked about the four-wheelers, and four-wheelers are very similar. Even trucks have similar capabilities, buses have similar capabilities. So four-wheelers more or less are ADAS capable. What about two-wheelers? So the ADAS equivalent in two-wheelers is also referred to as Advanced Rider Assistance System, right? So this is something which is work in progress, I would say. It's a Not many things are today available. Some things are available which can fall under the category of advanced rider assistance. But for example, the one of the features which many of the bikes today have is what is called a tilt angle. That is available, but beyond that tilt angle, at least very few features related to ADAS are available. So We are going to look at few use cases what ADAS can have potentially. It's an open area. It's a greenfield area according to me. For those who want to do a research or those who want to get into entrepreneurship. So, there's a vast scope that can be done as a part of ADAS. Having talked about, the vehicle and its relation to the infrastructure. So the vehicle is equipped with sensors. The infrastructure is equipped with certain sensing, that is basically cameras. We can also have radars. We can also have certain positioning systems equipped in the infrastructure. And if we can aggregate all this data, then a set of use cases emerge that 5G can enable. And the next 4 or 5 slides, we are going to talk about these use cases or these categories of use cases. They're not specific use cases, right? So the first among them is called as cooperative maneuvering, right? So this is a class of use case, and lane merger today is one of the use cases in cooperative maneuvering. But this use case is sharing the local awareness, and you might have come across these situations when you are driving your vehicle, either be it a two-wheeler or four-wheeler. When you're joining an intersection on a highway, you are at a blind spot. You do not know what vehicle is merging onto the lane that you are going to go into an highway, right? So creating that local awareness that there is a vehicle that is coming. Let us say I'm driving on this bylane that you see on this figure, and I get a notification from the network or from a cloud service or something like that, that there is a vehicle coming at 100 kmph. You will have to slow down to 30 kmph. Otherwise, there's a possibility of a crash. I mean, okay, I'm describing it verbally, but some way of communication, right? That there is going to be a possibility of an impact or a crash if you continue driving this fast, right? So in general, what cooperative maneuvering is about is making, if we take a context. So context is, let us say, a circle with 50 meters as a radius, and we make every vehicle aware in that 50 or the 100-meter radius of, say, the relative position of every vehicle, the intent of every vehicle. So that is what is called as local awareness. And what are the driving intentions, right? So the driving intentions are easy. Speed is one indication of a driving intention. Braking is another driving intention. Acceleration is a driving intention, right? So if we are able to make the vehicles in this vicinity aware of these driving intentions, then the others can take appropriate actions, either manually, or there can be an automation algorithm also possible of, say, auto braking or slowing down or accelerating to join fast, whichever way it is possible. So this is what cooperative maneuvering is about, right? Now, if we look at the technology challenges, if we were to solve this problem, right? So uh, some of the challenges I have listed, I mean, there are several of them. So the most important part of them are probably, that come top in the agenda list, which impact developing a solution for this. So common interpretation of driving intentions, right? So what is a common interpretation? In the sense that, look at it this way. So I am driving at 100 kilometers per hour. The other person is driving at 120 kmph. So for the person driving at 100 kmph, a person at 140 is accelerating. But if there's another person driving at 200 kmph, the person at 140 is actually decelerating, right? So it depends on not only on decelerating in the sense he is coming slower or the merger distance is higher, etc., etc. So not exactly decelerating. So the interpretation between the vehicles within a given region is not the same. It is different for different vehicles depending upon your own context, right? And given this data at that speed and at that computation level, are we able to determine a personalized interpretation of everyone's driving intention, right? So this is one of the challenges in this data aggregation or data fusion. Then comes in joint optimization trajectories, that based, assuming we solve the problem of interpretation of intentions, we come to know that, hey, he is going to accelerate, he is going to brake, he is going to decelerate, etc., etc. Now, in the mix of all this situational awareness, how do you see the final scenario? Who is going to collide with him? Who is going to move in whose direction? Collision is the last case, of course. But can we then derive a general trajectory of what is going to happen in the next 1 second, 2 seconds, 5 seconds? Typically, in the automotive world, when we are talking about cooperative maneuvering, we don't go beyond 10 seconds. So what is going to happen within the next 10 seconds? Can we build a picture of that? How do you represent that picture? How do you communicate that picture? Is that decision taken centrally, or is that a federated decision? So these are all questions today which are work in progress at every stage, right? Then acknowledgement of maneuvering plans. So assume that, we somehow make these trajectories, or we somehow make these so-called actions or plans, and we manage to have some schema by which we communicate these plans to every vehicle in the vicinity. You have to ensure that someone sticks to this plan, right? So I don't know if you are, if you are follow, some of you might be following the avionics. So the avionics has something called as a TCAS, which is a collision avoidance system, right, on an aircraft. So in a collision avoidance system, the proximity of the aircraft to the aircraft is measured and communicated to all the aircrafts in the vicinity. And the pilots have to acknowledge. So it goes with an action also that, if you are in close proximity, one of the planes would be asked to go up, the other would be asked to go down, so that the separation is at same levels, right? But the pilot has to acknowledge to a TCAS message mandatorily saying that I am going up, and the other pilot has to acknowledge I am going down, because if they take opposite actions, then it is also a collision, right? So there is an acknowledgement process there. Now, in this, what is an equivalent of that acknowledgement process in the automotive world? Nothing exists today, right? Do we even have the time to acknowledge such a thing? Because the events in the automotive world might be very fast. You may not even have the reaction time to do it, right? So are these acknowledgements with a manual intervention? Should they be automated? Should they be action oriented? So these are fairly open things. So right now, even at an L5 level of the vehicle, only autonomous driving vehicles have acknowledged maneuver plans. Any level below level 5 today does not have an acknowledged maneuver plans. So that's again an open area. Then what's the authenticity of shared information and timely communication? So these are some of the challenges. I might want to hack into this and feed the network with the wrong data set so that the crashes deliberately occur, right? So this is so these are some of the challenges in cooperative maneuvering. Let's come to cooperative perception. Cooperative perception is ability to extend the local perception beyond the line of sight. I mean, a very common example, when we have a truck in front of us and we are trying to overtake, we are unsure whether there is space in front of the truck where after overtaking I can get it, right? So I still do not have that information with me, and there are several such situations. Several use cases emerge out of a cooperative perception. So is it possible for me to create the image of what is available in front of the vehicle in my map? Right? Today maps, they tell me only where I am. They don't tell me where others are. Right? But if I look at a 5G network, if assume all vehicles are connected, this information of relative location is available to the network, right? What is the relative position of the vehicle? Now, if this information can be made available in the map, I think that's a fantastic value add, right? So that is exactly what the cooperative perception is. And if this information can be augmented with the sensed data of the vehicle, even better, I get more accurate information, right? So this is all about cooperative perception. Some of the challenges that are involved here are multi-vehicle sensor fusions. There's a sensor data from different vehicles. We will have to merge all those sensing information. We will have to merge all the network information from it in order to derive a common picture. Map merging is a very tricky topic or topic of research right now, that the different vehicles might be logged on to different mapping services at different accuracies, right? They may not be with the same network provider in a 5G world also. And different network providers or different satellite networks that use the GPS, assuming we use GPS for location, might have different interpretation of the given location. And the closer we get, the resolutions are different. Then how do we create a common reference out of this various informations or various temporal and spatial information? That's the challenge. Different vehicles might have different sensors calibrated with different precision, accuracies, etc. Each sensor will have its own drift. How do we compensate for that in our data fusion algorithms is another area. Time synchronization. Not necessarily every vehicle is on the. So look at it. You have a visual reference, but look at it as a system. As a system, the clocks of each of the vehicles that are participating in a cooperative perception algorithm need not be time synchronized. They might be talking to different time servers. The time servers might have a drift among themselves, or the satellites that they use for time syncs might be different. So how do we do this time synchronization? And of course, the last but not the least is how do we communicate this? Should we show it on a map which the user is using? Rather than showing a single vehicle on a road, shall we show the relative positions of all vehicles on the road? So today Google does this by just showing a red line, or let us say a green line or a blue line saying there's no traffic, right? So it is doing some sort of a user experience, or it is doing some cooperative perception in terms of aggregated traffic density. But that aggregated traffic density is not sufficient to take vehicle safety decisions. It just doesn't have the fidelity of doing a vehicle safety decision. So that is exactly what user experience will be, that how do we enhance the mapping service, or is there some other way by which we will communicate to the user on this, right? So this is cooperative perception. The other class is cooperative safety. Cooperative safety is more about pedestrian safety, or VRUs, vulnerable road users, who do not have any sensing on themselves and have to rely on infrastructure sensing. So let us say you're standing on a road, or you are trying to cross a road, and there is a speeding vehicle comes at, there is all the probability that it will crash into you. How can we enable such a use case where both the vehicle and the user are alerted about an impediment, or are alerted about a possibility of a collision, right? So this is what is cooperative. This is again just one of the use cases. This can be extended to multiple use cases in a vehicle safety context, of vehicle to vehicle crash, vehicle to pedestrian crashes, speed control limits on vehicles in the presence of objects, road blockages, so on and so forth, right? So that is what is cooperative safety. Some of the challenges in it is, reliable detection of VRUs, vulnerable road users. So road users themselves probably in today's world have cell phone, right? Cell phone data, and relative positions can be acquired via the cell phone data if they're connected to the same 5G network. But beyond that, we have to rely on infrastructure sensing. Based on infrastructure sensing and the network data, how can we do proximity estimations, right? Uh, Vehicle to vehicle communication is relatively easy because they might be logged on to the same RSU and we might be able to figure out a way. But how do you do a communication with an VRU? So I am seeing a person, and somehow if I build some algorithm saying I'm able to detect a potential crash, I should be able to inform the user, right? Maybe as an alert or maybe as, and the user, it should be in a way which is non-distractive, right? So how do we communicate with the with the VRU? So that's a big area of research actually. Then a common frame of reference between infrastructure and vehicle sensing. The same picture should be created based on the data acquired from the infrastructure and the data that the vehicle generates. How do we overlay both the data? This is not only a sensor fusion problem, but this is also a frame of reference problem, that both of them should be generating the same frame of reference or have the same view of the context and the situation, right? So occlusions, how do we address that? Intent, how do we address that? Become a part of this cooperative safety. Of course, we can bring it down to very constrained problem definitions and try to solve it one by one, but that's a topic of another discussion probably. And last but not the least, communicable identity of the VRU. So communication to the VRU is one part of the story, which is more about user experience, how to communicate. But how do you detect which user I should communicate to, right? Would you rely on the infrastructure to communicate? Would it be an intent-based communication that maybe the user that is closest to the asset where there is a higher risk, you decide to communicate first? How do you decide, how do you get the mobile identity of the user under a GDPR rule, for example, where, you know, it's not very easy to get access to identities, right? So these are certain areas of cooperative safety that need to be looked at. Autonomous navigations, we all know of this, but because there is a lot of talk about autonomous vehicles driving on roads, there are so many startups that are getting into this, so on and so forth. Here it is not only about autonomous navigation, but it is also about augmenting the available information with hyperlocal real-time information, right? So what is hyperlocal real-time information? Every car, as we saw earlier, has a lidar and a radar. So they are actually sensing the information in and around them. And as I said, they are consuming the information for themselves. But if this information is made available to the external world, we can do much more. For example, if there is a blockage on the road, or if there is a lidar, for example, I can get a very accurate picture of the road condition, right? That there is a ditch here, there is a water collection here, there is a road diversion here, which is not available in real time in a mapping service. Google has started this to a certain extent, but that is with user intervention. Nowadays, you will get an alert. There is an object on the road. Do you confirm yes or no? Right? On your mapping service, you will find this. But that is just with manual intervention. So someone reports something and Google then asks for people that, will you confirm this? And then if maybe there's an algorithm which says if 10 people confirm, maybe I will say that there's a road on the object. It is not automatic as of now, right? But this is exactly what a 5G network will enable. If we aggregate or start using the car itself or the vehicle itself as a sensor, it is so rich in sensing information, right? So there was a project from TCS, if I'm not wrong, wherein they used the radar and the lidar in the car as sensors to detect empty parking spots, It was a very nice pilot they did where, when I'm traveling along the road, this senses empty parking spots on pre-located areas and reports that to the cloud saying, hey, look, this is an empty parking slot. So that was a very simplistic use case, but 5G can really enable very complicated or real hyperlocal information that can enhance the map and provide me with much detailed navigation or suggestions on selecting the right route. Right. So this is what is autonomous navigation. Some of the challenges, how do I update the maps in real time with my sensed information? How do I ensure the authentication of my sensed information? What is my navigation strategy? How do I change my route in real time based on that? And then the main challenge is working with heterogeneous maps. So this is more about standardizing the map representation. So today there is a layered representation in a KML format, or there's a bunch of formats today available. Is that format semantically, it is syntactically rich, but is it semantically rich enough to accommodate such hyperlocal real-time informations? Right? It's still a debate going on around that. And we need to look at that, and then based on that, how do we do the navigation computation or distributed route, so on and so forth. So these are some of the challenges in autonomous navigation systems. And last but not the least of the use cases is remote driving. So a valetless, say, parking is the simplest of use case I can think of. So the valet is at a remote location, you give him the car keys and he drives it. Your infrastructure is equipped with cameras, your car is equipped with cameras. So it is like sitting in a call center and driving your vehicle, right? So while this may not be a very lucrative use case in an on-the-road scenario because we have autonomous driving vehicles, but off-road applications are tremendous, right? So we do not get, let us say you have an agriculture tractor and I convert that tractor into an autonomous or a remotely drivable vehicle. I can sit in a call center and I can drive the tractor sitting in a call center and plow the field. I need not employ a person to go there, which appears to be the biggest challenge today in the Indian scenarios, right? So there are certain set of use cases that come about from a remote driving perspective. Now, some of the challenges is safety, navigation in the presence of objects, especially humans. How do you avoid that? Real-time control of information. So far, we talked about information coming from the vehicle. So let me say the uplink was a high bandwidth requirement, downlink was a low bandwidth, low latency requirement. But in this case, the downlink is probably a relatively high bandwidth and an extremely low latency requirement. Because if I sit, let us say, in my home with a steering column or the steering simulator driving a remote vehicle, the slightest touch on the accelerator pedal or my brake pedal should immediately reflect on my vehicle, right? So how do I establish that real-time control information gets communicated at that quality of service is something that is a topic here. Then what if my network fails? Right, we have to address that condition as well. Networks, though very reliable, we claim there is always a possibility that the network might fail, especially in Indian conditions. Then the vehicle should have a decision-making capability on its own. So that is, how does it make decisions at the edge if the network connectivity is lost, right? Then we have security. Again, security is about data corruption, about someone doing a cyber attack on the entire system, so on and so forth. So that is another area that is to be looked at. And cooperative movements. If just like we talked about cooperative maneuvering, there you have the driver on the vehicle, right? But here, let us say you have two vehicles within the same vicinity, but two drivers are remotely driving it, right? Then this opens up a Pandora's box. Not only the vehicles should be safe, but the same information of what the vehicles are seeing should be communicated back to the driver, so that so driver in the sense the user who is remotely controlling the vehicle should be able to see the same scenario. So there are certain challenges in that. So cooperative movement in case of multiple operators becomes a challenge. So broadly speaking, in an ADAS system, or when we talk about enablers of 5G, these are predominantly the 5 categories under which most of the use cases can be mapped, right? So uh, uh, and the challenges more or less are what I discussed at a very high level. I mean, of course, deep down there are several details which probably we can take up at some other point in time. In the interest of time, I will go over the rest a bit fast. Now, given that we have to implement such a use case, if we have to do an requirement derivation, this is just one example of a requirement. So you will have automotive requirements, you will have network requirements, and you will have some qualitative requirements. There will be, of course, a lot of other detailed requirements. It's not so simple that we stop at this, but this more or less conveys the gist, right? So we will have to, when analyzing a use case, we will have to look at the automotive requirement, especially, what is the localization I need, or what is the accuracy of my sensing is what localization means in this context. To what is the minimum distance, minimum car distance I should get recognized that there is an object in front of me based on the algorithm. At what speed am I driving, and what should be the accuracy of the speed recognition that I should have. So these are some of the automotive requirements. We will have certain network requirements in terms of communication rate, data rates, latency, reliability, etc., etc. And then the cost and power consumption, of course, and the security part of it, right? So whenever we are doing our requirement engineering for this use case, in trying to identify what kind of sensors I should select, or what kind of network requirements I should have, or what kind of software that I'm going to do, these are certain exemplary ways for this. Now, the rest of the things I'm going to talk a bit about ADAS. So just to set the context, this slide is taken from Ministry of Road Transport. As you can see, 60% of the vehicles involved in a road accident are two-wheelers, right? One of the vehicle is a two-wheeler, or the pedestrian, right? It's an enormous number. So pedestrians, bicycles, and two-wheelers together form almost 60 to 65% of the road accidents, especially fatalities, and 80% of the fatalities are in this category of all the fatalities. And then if you look at where the accidents occur, most of the accidents are occurring around a junction where there is a blind spot, or you're not able to see the other vehicle, or you're unable to judge the speed, so on and so forth, right? So there is definitely a need to build something like an advanced rider assistance system in this. Now, what are the use cases that emerge out of this? So I've listed some top few. There are definitely several others. Again, as I said, this is just to kickstart your thought process around this. Tilt detection. So whenever I'm taking a turn, my bike tilts. Can I use my accelerometer to detect by what angle I'm going to tilt? And if I can detect the angle by which I'm going to tilt, I would be able to control my speed better, or I might auto-select a speed in my vehicle ECU such that it doesn't allow me to go beyond a certain speed. So there is an immobilization. If tilt detection can be linked to vehicle immobilization, that's the use case that emerges here, right? The other is e-call. So whenever there is a crash or the fall detected, can we auto-initiate an emergency response? That is, if the vehicle is a connected vehicle, means it has the capability of sending an SMS or making a call. Why doesn't the vehicle, if it gets crashed, and assuming that the telematics device is not destroyed, it makes a call, But more than that, can the infrastructure initiate it even if the vehicle is destroyed? Right? The infrastructure knows there is a crash. The infrastructure also knows the identity based on probably the eSIM or whatever goes into the vehicle as a communication identity. So e-call systems today are vehicle oriented. Can they be infrastructure oriented? Right? So that is the use case here. Then airbags as apparels. So on a two-wheeler, I mean, today they are very expensive. You get a jacket which is an airbag. So when the vehicle detects a crash, there is a Bluetooth communication between the jacket and the vehicle that on a crash, when you fall down, maybe the jacket has a sensor. I'm not too sure. Yes, I do know that when you ask this jacket with some of the high-end bikes like BMW and all, it also has a sensor. When if detected, it is inflated, right? But can we do this in a more economical way for the developing nations like India? What kind of safety measures can we do? Apparel airbags is probably one of a very, very new area that needs to be looked at. Smart helmets. Today, helmet, I mean, we just have a helmet because the rule says we have a helmet, but they're pretty much, I think, of no use because of the various considerations. But can we make them smart? I mean, we do get helmets with probably, a speaker and a headphone in it. But that's not what is smart. Can we have an HUD, a heads-up display inside the helmet visor? Well, what you see on the bike's display or the HMI gets displayed inside the helmet, right? And with EVs, battery safety, thermal runaways, can we get early warnings, diagnostics and prognostics, and the heating element of the battery? Can early responses or can early things be done with this? And then pay as you drive is an insurance use case. So you incentivize payment based on how you are driving or the driver's parameters. This is a topic in itself. Probably sometime we can get into the details. So these are some of the use cases in the ADAS. I'll take 5 more minutes. Some of the cases we talked about is accident and crash detection. So parking violation and parking circulation time. This is a very interesting use case. There is a statistics which was carried out by one of the organizations. If I was not wrong, it is the London Transportation System, on how much fuel is wasted in searching for parking lots. And I think the number is something like a couple of billions per year, globally, I'm saying, not India specific, right? Huge number, just searching for parking. So this is called as parking circulation. That is, you are inside a parking lot. So and inside the parking lot, you are just going either up and down if it is a working parking lot. If it is an open parking lot, you are just circulating around searching for the parking space. And this is a huge fuel loss, carbon credits, etc., etc. So can we use sensing technology or even 5G to actually direct a user directly to an available parking space, right? Parking slot rather, not space. Then comes in hazard notification of any object on the road. It's a very low hanging fruit, probably can be looked at. The other two use cases are theft detection and towing detection. They are very relevant in an Indian context. How many times you have faced that your two-wheeler has been towed away by a police because you parked it wrongly, and then you don't know where it is parked, where the police have taken it. So you spend a lot of time with that. So can we have a towing detection enabled on the vehicle, which is an AI ML plus an infrastructure sensing kind of a thing, and then based on that you know where the destination of the vehicle is, and you are alerted that your vehicle is being towed away, and so many use cases emerge out of that, right? Okay, having talked about this very quickly, the conceptual framework, we will have sensors, we will have some kind of an acquisition which is about information collection, we will have some kind of an edge computing unit, in the edge computing unit, we will have some AI ML algorithms running, which can be run on the vehicle, which can be run on the infrastructure, but which can also be on the cloud itself. Then we will have certain cloud computing services, and this is a federated model. Based on this federated model, we can then arrive at certain conclusions, and the messages then can be or the control outputs, or the alerts, or the events can then be communicated to the end user, right? So this is more of a conceptual framework that we are talking about here. Then there are certain data challenges that go in. The data challenges, is we are asking for data from the vehicle. We are asking for data from the infrastructure. So there has to be some data ownerships. People have to be incentivized to share that data. There has to be a framework where people are given the choice that which data they want to share, which data they do not want to share. We have to come out with interoperable data formats. We have to come out with some audit trails for the data, so that if there is a monetization possibility, that can be explored along with it. So all of this come as a part of setting up this data framework in a 5G network, which today it is assumed that users will share the data. I'm not too sure if this assumption will stand for very long, considering that GDPR and even India, we now have a data sharing policy. So right from a design phase, we should be aware that data doesn't come for free. And then if data doesn't come for free, then what are the enablers we should build so that we enable, at least at an architectural level or the framework level, that if the right policies come in, then we are in a position to accommodate that, right? So that is all about the data challenges that need to be addressed. Broad level framework, there would be certain triggers. There would be a strategy deviation from the trigger. So proximity or object detection can trigger something. Then I have to devise a strategy from it. Based on the strategies, we will have to derive certain gain function. If I do this, what is my gain or loss? If I do that, what is my gain or loss? Based on that, certain outcomes, and based on that, certain alerts, notifications, or controls can be enabled, right? So this would be the high level flow of any framework or any ecosystem that we try to build, or any algorithm we try to build at a very high level. And then we will have a physical layer. I'm not going to get into the details of this, because this is, it's going to take some time to run through this. But in principle, we have a physical layer where infrastructure and vehicles provide me with the sensing information. We have a fog computing layer. Then we have a multi-access edge where I can run my edge algorithms. And we have a cloud computing layer where another layer of computations and AI ML or learnings, reinforcement learnings, or any other type of learnings can happen. And the model gets pushed down into the network. The idea being, keep your decision making as close to the edge as possible, but offline do the computations on the cloud. That should be the philosophy that drives this reference framework, right? Now, if I come to a common interface, if the thought process that we are also looking at or driving out of ArtPark is, can we build a digital public interface for this vehicle safety? Even if my vehicle, if I agree to share certain data comes from the infrastructure. Vehicle safety should be something as simple as the unified payment interface, right? Someone should be able to consume the APIs and build intelligent applications and offer it as a service. So can we create such a digital public infrastructure? It is still a topic of research. It's a thought process right now, but that is the thought process. And if we have to go in that direction of thought process, we will have to build certain common services. Can we split down the 5 or 6 categories of use cases into certain common services? For example, object detection, path computations, platooning, network selection, traffic monitoring, etc., etc. These are all common services which can then be combined or orchestrated at an application level in order to build a rich experience. So, incident detection, so cooperative navigation, what I talked about. So if we take an example of collision warning, right? Collision warning is a combination of an object detection, a path computation, and a sensor fusion, for example, right? If you orchestrate these services, right, you can in principle build a collision warning system. So that is where we are heading to, or we are trying to look at if we can build a digital public infrastructure in this direction of vehicle safety. I'll stop here. Sorry, I ran 5 minutes more than the time allocated, but I'll be happy to take questions if any.
Thank you, Dr. Lele, for an excellent presentation. Questions, please. Hello, any questions from the participants?
Sir, I had put it up on the chat. So what are the top three vulnerabilities in an ADAS system?
So there are several. There is nothing like top 3 vulnerabilities. So it depends. So there is no vulnerability as such. So ADAS itself, the biggest vulnerability I would say is the sensor. What if my sensor is not calibrated and not accurate? So vulnerabilities themselves can be divided into 2 parts. Are we talking about vulnerabilities from a classical security point of view? Are we talking about algorithm vulnerabilities? Or right now, there's also a theme emerging which is called as vulnerabilities related to responsible AI. What if my algorithm itself is biased? Right? So it depends on how we are looking at it.
More from a security perspective.
From a security perspective, so in a security perspective, you are as good or as bad as how your architecture looks like. What is so let us say you are using a WebSocket without a firewall. So ADAS itself will not have any security vulnerabilities, right? ADAS is algorithmic. ADAS is implemented on top of sensing networks which run on a communication layer, and then it depends upon what communication layer. So my answer to that would be we are as good or as bad as the tech stack we have. And when I say that, let us say if we are working on a Wi-Fi network, you just look at the CVEs that are there in a TCP version X. Those are the vulnerabilities for the ADAS.
Okay, yeah. Thank you.
Are there any other questions? If not, thank you, Dr. Lele, for an excellent presentation.
Thank you so much.
I request all the participants to fill out the feedback form, which is shared through the chat box. It's very important. We request you to fill out the feedback form, please.
Okay, thank you all.
So that brings us to the end of the today workshop. Thanks to all the speakers, all the participants, and the skilling team at Art Park, which made this possible. Thank you all, and I once again request you to fill out the Google form as feedback. Bye-bye.
Thank you. Sir, I have a question. Mr.
Yes.
Srishankar, yeah. Yeah. Thank you for organizing this. Would the slides be made available?
It depends on how many of them have shared them, and if
Yeah.
they have shared them, yeah, we will work on making them available to you.
Okay. And will there be any certificate of participation be provided?
Sushmita, do you know about that?
Yes, yes.
Okay.
Will there be a certification of their participation, Sushmita?
Sure.
Okay. Yeah. All of you will get a participation certificate.
Thank you. Thank you.
Thank you, Sushmita. Yeah.
Sure. So it was a well organized session. So yeah, it's Chetananand here, and this was a well organized two-day event, giving a lot of insights into 5G, how technology is changing, how the regulations are catching up, and what are the risks and opportunities that is being presented. So, with regards to the schedule, yeah, it was actually, I think, a tightly packed schedule. Maybe a gap in the morning today would have been good. So, otherwise, it's a very nice initiative. We look forward to attending many more such workshops. Thank you so much.
Thank you. Anybody else, please? A verbal feedback? We would welcome your verbal feedback.
you.